6-person panel. Hand it around, yeah. So there's 2, and then where's the 3rd? Ah, okay. Thanks, guys. And then it's on the bottom. You'll control it. Fantastic. Okay, so don't touch buttons. Test, check. All right, awesome. Hey everybody, my name's Remy. I work with 0x Park. I'm pretty much just going to be a timekeeper today and a little co-MC to keep things running smoothly. Justin and the folks from our Autonomous Worlds division and the Lattice team and all of the other teams you'll meet. They'll be the people who are up here the most. Just want to give everyone a heads up that our kind of formal programming starts at 12:15. So that's when the first talk will happen. So you do have I'm at 10:15. Obviously, I need to drink that coffee that's in the corner. So you've got 13 minutes. If you do want to grab a coffee, hit the washroom, anything like that, 13 minutes until we kind of officially kick off. If you want to see the schedule for the whole day, if you go into the Devcon scheduling app, so app.devcon.org, and you click on the SLS session, the Autonomous Worlds SLS session, there's a Notion doc that's linked in there. And that has the full schedule for the whole day. So we have a mixture of talks, lightning talks, game demos, a panel, and then at the end of the day at 2:35, is that correct, Flo? 2:35? I'm pretty sure that's correct. Then that'll be the last session, and that's kind of like a full showcase of the MUD engine. So yeah, if depending on what you came for, game demos or kind of more theoretical talks, or to really see the game engine that's been developed, I'd recommend checking out that Notion doc, and then you can kind of plan your day accordingly. But like I said, we'll kick things off at 10:15, and thank you so much for coming. We're really excited to have you guys here. So see you back in a few minutes.
the lab, the link on the MUD website is basically links to the lab.
Yeah. So maybe I'll encourage you to go like there as well. I'm gonna post the schedule. Oh, it doesn't? Just Dev? Justin, you can take a second. Do you have presentations or is it just talk? Okay, do you want to get that set up and I'll just kind of... Oh, okay. Hey everybody, thanks again for your patience and thanks so much for coming out. For those of you who have trickled in since the last time I talked to the crowd, my name is Remy. I work with 0x Park. As I mentioned before, I'm just going to kind of be the timekeeper today and a little co-MC with Justin. We're just getting his slides up, and while he's doing that, I'm just going to give you guys some more information. I've kind of hastily written up the schedule for today. There's not a ton of information on this whiteboard because I couldn't write it all on here. So if you want to see who actually like all the speakers are and a little bit more description of some of these presentations, lightning talks, panels that are happening today, I really encourage you to go to the Devcon schedule, click on the Autonomous Worlds SLS event, which is the one you're in, and then in there is a link to a Notion doc with more detailed information for the schedule. I'm also going to go into Lattice's Discord and post that link into the Discord for Lattice. And if you want to access that Discord, whether for that link or for following up with any of the folks you're going to see today or learning more about the stuff that Lattice is working on in MUD, you can go to mud.dev. I was just told don't put www, just put mud.dev in your URL, as the URL, excuse me. And then the Discord link that links from there is the one that will take you to the Lattice Discord. And I'll try to kind of drop some information about the projects and the teams in there as we go along today. And I think that's enough housekeeping stuff. Are you feeling good to go? All right. So could I get a warm round of applause for Justin, who leads up, thank you, who leads up the Autonomous Worlds wing of 0x Park and also leads Lattice. And that's enough intros, I think.
Thank you, Remy. All right. Hey, everybody. Got stuck in traffic, but here I am. So yeah, my name is Justin. I'm co-founder of 0x Park, and today we have a lovely self-led session about autonomous worlds. So before I kind of give it away to the people who are going to go through demos and talks and panels today, I want to give a little bit of context about, okay, what is 0x Park? What is autonomous worlds? Why are you folks here today? So kind of like the story of 0x Park is really simple. There were a bunch of people working on this on-chain game called Dark Forest. And I happened to go to Mexico after a Twitter DM and live with them for 3 months. And we were like, okay, let's start something together. And so myself and a subset of the people there created this foundation called 0x Park. Remy joined us like a week in, and then a bunch of Michael is here too. He works with us. So we have a couple of like awesome people trying to essentially advance the plot. So what we mean by advance the plot is doing things that push the industry forward in a way that is basically kind of like nonlinear step function. So usually I would say the way you kind of like make things move forward is by running conspiracies. So you bring people together, you kind of like try to instigate a scene, and you make sure that everybody feels like the work they're doing matters, but also that they're onto something that people are not aware of. So the first 3 wings of 0x Park when it started was applied cryptography. So we funded a bunch of people and coordinated a lot of learning groups around ZK and stuff like that. We had Ivan working on Dark Forest, so they were shipping new Dark Forest rounds. Andy, who is here, was working with Ivan as well, just basically grinding the game out for like 6, 7, 8 months, and they did very cool stuff. And we had 2 people, so Alvarez and I, working on Lattice. So for a long time, it was just like 9 months of research and soul searching. Our goal was to advance the plot of on-chain gaming. So how do we get more people to be able to build those large EVM applications? How do we figure out the design patterns that allow for those things to become way more interesting than they are right now? And like our 2 outputs after that research was a blog post trying to define what we mean by autonomous worlds, and a piece of technology called MUD. So that MUD is a game engine for on-chain games. And shortly after that, we built 2 kind of like cool products that we're going to show you today during the demos. So what we mean by autonomous worlds basically is any large on-chain system where autonomy and sovereignty is important for emergence to happen. So kind of like the way I talk about it is, I think Ethereum mainnet is the best MMO out there, but it only caters to Homo economicus, so people that are obsessed with like money and competition. And one thing I really care about is the fact that I would like society to be a bit more playful. So how do we create basically systems for Homo ludens instead of Homo economicus? And the way we define autonomous worlds are systems that have autonomy, formalized rules, and emergence. So if you think about Ethereum mainnet, it has those properties, but Ethereum mainnet is like a very kind of like non-skeuomorphic alien place to most of us. The thing that is interesting with Ethereum mainnet is its multimodality. I can interact with that MMO by doing a swap on Uniswap and coexist with MEV bots and a lot of horrible stuff that happens there that nobody has any idea about. So it's a pretty great system, but how do we create more things like that that feel slightly more human and are slightly more pro-social? Because Ethereum mainnet, I mean, we're all here together because of Ethereum mainnet to some extent, but I would argue that we can build systems that get people to make more friends and build more relationships. And the reason why I think autonomous worlds are quite important is because just like a lot of people make fun of NFTs, but the one thing that is interesting with NFTs is that they're on-chain values. Like most tokens out there actually have references to off-chain value. And the thing that is interesting is an NFT is valuable for the sake of it, right? And kind of like, if you keep building those systems that are more and more complex and have more and more like immersion into them, it's like real on-chain value, real on-chain drama, real on-chain history. And we think that this is going to unlock a lot of applications that first will need that like trustless oracle to those data before becoming more useful, as an example, to like off-chain stuff. So as an example, identity makes way more sense for autonomous worlds at first because you don't need this ugly kind of like meat space, cyberspace bridge. You can refer to things that happen on chain that can be verified. You can refer to real relationships that have been like, that we've reached consensus over in the EVM. So it's kind of like a way to bootstrap a bigger ecosystem when it comes to like Ethereum technology and like pushing the envelope, basically. And my belief is, I think autonomous worlds has a shot of being the biggest usage of gas and attractor of attention in Ethereum over the next cycle of technology. So basically the technology we have right now caters to, hey, how do we get DeFi and NFTs to work, right? Like roll-up companies today, their go-to-market strategy is take the stuff that works on Ethereum mainnet right now, make it cheaper. What happens if we push the envelope further, right? Like what happens if we live in the future and we unlock new affordances? So yeah, I think that if you want to build autonomous worlds today, you need to live in the future, which basically means you need to kind of like cut corners or give up some form of security or whatever, but you need to project yourself to a place where, as an example, we'll have 1 trillion gas per second, right? Like what does the world look like when we have 1 trillion gas per second? I think that right now, a lot of like applications, ideas are kind of like driven by scarcity of on-chain computation. So people do super crazy stuff with like scaling, ZK, FHE, MPC and stuff like that. But I think that one thing that is going to be quite interesting is what happens when we level up from an Apple II computer to an IBM mainframe that is Byzantine fault tolerant. We're going to have quite interesting applications. But today, if you want to do that, you have to cut corners. A future with on-chain physics. So what happens when we can kind of like simulate rules that have conservation laws that can be verified on-chain, right? Like, can we go towards something that looks like a digital planet, you know, like kind of like Mars, but it's digital and it has always been there. Nobody can shut it down and people can go there and do stuff. Like what I think the internet would be more interesting if we get there. I think we also need to live in a world where we have multimodal interactions. So right now, when you think about video games, they're mostly like they have one modality. So if you play Fortnite, you play Fortnite with a client and that's it. You can talk about it with your friends on Discord, but that's all you can do. I think the one thing that is interesting when you build systems of rules that don't necessarily have goals is that you have this multi-modality that come in where people can interact with those set of rules in various different ways. To go back to the Ethereum mainnet as like the best MMO right now, it's multimodal. I can coexist with the MEV bots, the Uniswap developers, and the client developers. We're just like different types of people that interact with the system. So yeah, like let's try to live in the future and pretend that we have the design patterns we need to get that multimodality. So kind of like what happened after we instigated this little like autonomous world wing of 0xPark, we got a bunch of people that showed up and we started funding them. So DF and Lattice have been there since the beginning, but we started funding DFDAO, who have been doing a really good job on kind of like extending Dark Forest and trying to make it more playful and simpler for normal people. Nalin built Xgratia, which is basically kind of like 2D DNS for smart contracts. You can deploy smart contracts on the grid and interact with them. So we started having a bunch of little experiments. And then we kind of grew further. So we brought more and more people to London, where we're running an autonomous world residency. And we started doing essentially this thing where, hey, let's try to create a scene together and build things for each other. Like, how do we create interdependence amongst this ecosystem? There's a lot of cool stuff that is coming out. A bunch of people are going to talk about what they've been working on today, so I'm not going to spoil anything. But yeah, solid team. And really, the thing we're trying to do right now is, how do we instigate a scenius? A scenius is like, if you add genius to scene, you get scenius. Brian Eno came up with that term. So scenius is basically like the intelligence of a whole group of people, which is more often than not greater than the sum of its parts. Because no single company or group can create an entire industry. And if they do, more often than not, they suck up all the oxygen in the room and it becomes very boring. So how do we coordinate in a way that is like basically positive sum? And I know this term is kind of a meme today, but I think it's really important. So yeah, what are we doing right now? How are we actually advancing the plot of autonomous worlds? Well, through toolings. So Alvarez is going to talk about MUD today. Other people are going to talk about like maybe other things, but through tooling, better applied cryptography, better design patterns, better scaling, coordination, and funding. We're trying to essentially bring this model to a place where there's not just one cool project out there that like satisfies this definition of autonomous worlds, but many. So yeah, we're just starting to advance the plot. And the agenda today is you're going to see demos, some talks, a panel and lighting talks. There will be a lunch break in the middle. And yeah, enjoy, folks.
Check. Hello. So we're just going to take a few minutes here to get all of our demo folks up here who are demoing for the next session and get their computers set up. We're running a little bit ahead of schedule, but I think we'll just roll with that. Ahead of schedule is better than behind schedule. All right. Check, check, check. Awesome. So we're going to do 3 kind of fast-paced demos. And the first one is going to be Alvarius with OP Craft. So I'm just going to hand it off to him.
Cool. Thank you. All right, I'm going to show you OP Craft, which is a little game that we've developed over the last couple of weeks using mud. Using mud, because we used mud, it was possible to implement this game in a couple of weeks. The best demo is actually to just go to opcraft.mud.dev if you have your laptop here and try it out yourself. This is a world that is procedurally generated and infinite, and everything happens on chain. So if I go here and mine a block, then that is a transaction that is going to be sent on chain. And then here you see it got executed successfully. So now I have this item in my inventory. I can mine some more blocks. And I can, of course, also place blocks. And then the last thing I can do is craft stuff. But I need both hands, so I'll just put this here. So in order to craft stuff, I first need the right ingredients, of course. So I'm gonna go over. I'm gonna go over here to the wool tree and mine a little wool block, and then I can. All right. I can go over here to the wool block. I just mined a little wool block, and now I can open my inventory and place the wool block here, place a little flower here. Oh, there we go, and can create a dyed flower. There's a bunch of other recipes in this world. This has nothing to do with Minecraft, by the way, so the recipes are not the same as in Minecraft, in case you're wondering. But yeah, feel free to check it out. It's on opcraft.mud.dev, and we're very excited to see what you come up with.
Hello, hello. Did I have to do something special to hook up the video? Can I use this one? All right, hello. I am Kushaba. I work at Lattice making video games on chain. I was previously working at Dark Forest, and this is a demo of an on-chain RTS we call Skystrife, which will be launched soon. And this is a fully on-chain game. Each time you move a unit or attack something, it is a transaction. And as you can see, I'm battling my coworker right now. It's not doing anything. There we go. Okay. So this was built using mud. I feel like I've been shilling mud all week, and I just want to explain that even if they fired me tomorrow and told me I could never work on mud ever again, that I would still do it and see them in court. Like, that's how good this game engine is. And coming from Dark Forest, like, Dark Forest is a monolithic code base. It's an amazing code base. Like, it's the first usage of ZK in a video game, but it's not extendable. It's very difficult to add new features. Every time you add like a new concept of an entity in that game, it requires changes throughout the entire stack. And that became frustrating for me as a game developer. Like, you want to be pushing content out to your users. You want it to be able to add content really, really easily by just making a solid foundation, and then all the content adheres to that foundation. And I think that's the beauty of mud. Like, for the first, like this game has been in development for 3 months. The first month was basically making the game. All the on-chain functionality was done within the first month. And the last 2 months was just polish, like making a good client, making new units, like game design, play testing. So that to me is the power of this engine, like the power of ECS in general. It's like if you take these like limiting constraints of defining everything as a component and you make your game with that, you're kind of free yourself up to have a much more powerful development experience. And just to showcase like what this game is composed of, like we actually have a Unity style sidebar here where I could say, oh, let me check out this rider here. Here are all the components that this rider is composed of. And like the most generic component you can think of is position, right? It has an X and Y position. So these two components here, position and movable, anything with these components can move, right? If I add a dragon, if I add a golem, if I add a villager, if I want them to move, I just add position and movable. I don't need my move system to know what a villager is. It doesn't care. All it cares about is that this is movable, it has a position, and there's nothing in my way. And yeah, just to go through like kind of the complexity of this game, I've been amazed at how not limited I've been in my game design ideas. Like the only limiting factor right now is probably the fact that the blockchain does not have a tick function, right? Like if I wanted to make an NPC that walked around, yeah, that's pretty weird because someone is going to need to tick that NPC. But other than that, like I've been able to make all my game design dreams come true with this engine. And it looks like I'm getting attacked right now. So yeah, this little chain icon means the transaction is getting submitted when I'm attacking or moving. And this is basically, it is fully real time, but we have this concept of a turn. So every 60 seconds, each unit regenerates its action points, and those action points are used to do anything in the game. And that's kind of just a limiting factor for bots, right? Because since it's an on-chain game, it's client agnostic. You could write a smart contract to play this game. If it was completely unlocked, you could make any transactions you wanted at any time. Bots would dominate, right? They would just be filling up blocks with all their movements and moving perfectly, predicting everyone. Yeah, so if you join the Discord, I'm running like playtests pretty frequently. It's a pretty competitive game right now. If you've played StarCraft before, you'll feel at home. You should probably have a mouse. It gets pretty intense if you want to play. But yeah, this is what I've been doing, and I hope this inspires you all to make your own on-chain games. Thank you.
Test. Hey everybody, my name's Tony, and I'm one of the founders of the Dark Forest DAO. We are a community of players who started playing Dark Forest last summer and got so inspired by playing this first fully on-chain MMO RTS game that we decided to start building on it ourselves. So what we're seeing right now is a live game of Dark Forest between Valorum and Jim. In this game, you control planets, and you're trying to send energy between them to achieve specific objectives. This game has had a long history of iteration and development, and as Kushaba mentioned, it is kind of a dinosaur in some of the underlying architecture. But even with that being said, it's still really, really fun to play. And so at DFDAO, one of the things we've done is added some new ways for players to interact with this Dark Forest universe. One of the first things we did was make a single-player game called the Grand Prix, which is a speed run on top of the Dark Forest universe. So players try to get from point A to point B as fast as possible. But we missed some of the large-scale warfare that was super fun with the traditional MMO Dark Forest. And so for this conference, we put together a new game mode that we're calling the race or the quest for the antimatter cube, which is this new artifact that nerfs planets that it's on. So it makes it harder to move when you have this artifact in the game. So right now, we're seeing a battle for this cube in the center of the universe. And I'm not sure which player this is, but their goal is to try to send this cube to one of their extraction points, which is one of these planets right here called a space-time rip. So can we get a cube move from our players real quick? In case you didn't know, this game is also fully on-chain. The smart contracts are running right now live on the Gnosis Optimism blockchain. We're seeing real-time transactions taking place, and the client is fully open source, which has enabled people like us to build and modify further. So this is Dark Forest. Can we get a show of hands who here has played Dark Forest before? I'm just curious. Okay, so we got some fans in the audience. Awesome. Yeah. Anything else I should talk about? Okay, we're seeing the cube moving. Okay, cool. Well, that's a sign. Yeah, so this is the Dark Forest Antimatter Cube edition. If you're missing some epic warfare, stay tuned, follow us on Twitter, and maybe we'll have something that is large scale and involves the cube in the future. Thank you.
Thanks, Tony, Andy, and Alvarez for the demos. Now we're gonna have Arben GVN on stage for the talk. Arben GVN work on Moving Castle. It's a very interesting, if we can say so, project mixing identity, gaming, on-chain stuff. Yeah, I met them in Berlin a while ago. Thought they were very weird, and now they're here. So thanks for coming, folks, and on to you then.
Thank you. Yeah, we need a computer. Thank you for introducing us. It's the third time we've been called weird during this conference, which I don't know. Yeah. Thank you. We need a computer. I think so. I think we like to insult each other while going, yeah.
Just make sure you check.
Ah. Beautiful. Okay. I am, since yesterday, I don't get many possibilities to brag about this, the world champion of Sky Strife. I won the tournament yesterday, and I think this is a good moment for you to all to appreciate that. Yes. Thank you very much. Thank you. Oh yeah, look, clapping. Yeah. Oh yeah. Oh, thank you. Thank you. Thank you very much. Yeah. I don't know if I was the only one actually playing with that kind of intensity, but I loved it. Great. Should we do an intro before we
Yes.
we can swap around the order of the slides a little bit? Oi, 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 oi. Okay. I am Arthur. Hi, everyone. I have a background in, among other things, the blockchain space. I also co-founded a space in Berlin, which is called Trust, which is an online community, a kind of physical workspace. We do a lot of lectures and events. And we've been talking to the autonomous worlds, Lattice and 0x Park people for a bit, and it felt compelling enough to kind of come back into the space, I would say, for exploring the potentials of this.
I am GVN. I have a background in cinema, script writing, storytelling. Over the past 6 years, I transitioned to like real-time rendering engine and video games.
Yeah, Rasmus there, the man in the shirt. Wave Rasmus. is also part of the team. Great. Okay. So what we're going to talk about is clearly this. This is about autonomous worlds and decentralized narratives. I don't have any notes now, which is interesting, but we can roll with it. We already did this part. And so me and GVN started working together by writing this piece, which seems to have resonated with a bunch of people, which basically tried to start poking at the idea of what are the visual and like representational metaphors that decentralized organizations can have, and how can they come together in game worlds to maybe have different types of interactions. That was the basic premise of the piece. And through that, we started kind of thinking about game modes, kind of ways for different organizations to come together using games, according to this simple logic, where you have a world, you have a governance input from two kind of communities, and you can structure games that way.
And so what we built first was an instance of an Unreal Engine world, a game, that could plug into Twitch so that two different Discord communities that we worked with could kind of control the game through the Twitch chat. Yeah. And we also additionally built like an identity layer that would merge their tweet, or like they would like connect their Twitch identity with their Discord identities and would give them like persistent assets like skins or just like rewards or any type of values throughout the streams.
Yeah, this is how it manifested.
Yeah, the stream kind of looked like this. This is the first one. In the first one, we kind of try to like simply see how can we have like individual player represented, and what kind of game modes could these habilitate. And so the first test we did was like kind of like a pachinko-like game in which you would, through the chat, you would control a character. The character would fall down this labyrinth. Eventually, if you were lucky enough, you would make it into like a cave room where the skin that you have randomly generated would lock in, and you would have it into your persistent database, so you could play with it in every game. It's funny to see that although like the very simple mechanics that we tried, there were already like quite some lore coming up. Like, you know, people started like spamming the chat, obviously, and they like clocked the entrance, and then all at once they fell down. So yeah, it was kind of funny to see.
It's also worth mentioning that we saw this initial infrastructure as a way to prototype kind of large-scale game modes or communities that involved collective governance mechanisms. So we always saw it as like almost like interface experiments for on-chain logics. But this way of building it just allowed us to prototype very quickly.
Right. So this was another game mode in which all the players would control an individual character. And of course, when we had like around 250 players per session, and it's obviously a mess when like 250 people try to write left, right, or like move a character randomly. It's very funny, but also very complex. And obviously, we needed some governance mechanics to like make this a bit more efficient, a bit more playable.
Yeah, in this case, it was just everyone had to chant at the same time, and the character would move, which is maybe the most brute, like, way of doing it.
So in the next stream, we kind of like refined some of these mechanics. This was like a game mode in which the community would create their avatar representing them. So altogether, there were like basically two scale of governance. One was like the individual scale, so every player could control the camera movements and the pieces that were swapping. So this was like a modular character that we're building piece by piece. And the second one was like more like a collective effort to lock the piece in place, for example. So they all have to type at the same time, fill up a bar, and if there was consensus, the pieces would be locked in and they would move to the next part. this was the last stream we made, which was the most complex because both community came together to play against each other. There was also like that character in the back. It's Arb with a
That's me
motion
screaming in the
motion-
background
yeah.
about the game state.
With a motion capture rig, and yeah, and here we had like again like different governance model, but we divided into like turns, let's say. So the first one was like anarchy mode, in which everything that you would write would trigger an action. So there has been cases where like after collecting a lot of points, one idiot in the chat would spend them for the dumbest action, and there were like it was fun. We also had another mode. It was more like a democracy mode, in which they had to like reach a threshold before the action would be triggered. And we tested like many of these modes in this stream just to see like what were the affordances of each governance model.
Yeah. What was interesting with the whole process, I would say, is that if you kind of make governance part of gameplay, the failures of governance create the most fun experiences, I would say. I think there's a very different design space than like what we're maybe used to in the blockchain space more generally, where it's very frustrating. Yeah.
So this is a realistic portrait of us after 4 months of development. We made 6 games in total, produced more than 150 modular 3D assets. We had custom soundtrack. We had like motion capture rigs. We had collaborate with more of 8 artists for the production of all these assets in a decentralized manner. And we also work with the community themselves to generate the lore and like how the world would look like, what kind of assets should be produced. And it was, don't do it. The stream is stressful. But
yeah, live streaming as a format, although like fun, is also this combination of trying to build many mini games in a short time, while not being able to test them on not on the scale that you actually want to before, and then doing everything in a live stream format is a horrible idea. Don't do it.
Yeah, you just have to embrace fail. I mean,
Failure,
one thing
yeah.
we learn is like how to turn failure into like lore. I think that's actually a very like, I think it became like a core mechanic of the next things we were producing. But yeah, but we did learn some things. There were some like inherent limitations in these formats. Should I go?
Yeah, you can go.
Okay, so the first one was that although we build like this persistent identity for the players, the worlds themselves would not be persistent between the streams. So it was basically like kill the world every time and like restart the Unreal instance. Another problem was also exactly that. Although we collaborated with the communities to develop all the world building of these games, in the end, we were the sole owners and the sole gods of these worlds. They didn't really have access to restructure the rules of the games. And the third one was what we call group emergence. So we were designing tools for existing communities, but we were more interested in pivoting into like an environment from which the community could grow from within. So we decided that the only way to go beyond this limitation was to produce another game. We called it for now like a tragicomic NPC survival sim. And yeah, we decided that it should be on chain. You may ask why. So here's a good graph explaining it. So if we take these are like all work in progress, so don't take them too seriously, but take them seriously. So on the left side of this screen of the player agency graph, we have like worlds that are built from gods from within like a room that is inaccessible to players. The world that is produced is basically a dead world. Once it's created, it's never going to change. Yeah, some examples are, for example, Disney movies or the Bible. The only way players or viewers or users deal with these or engage with these worlds is through consumption, or through fan fiction if they really want to change something. The second, it's, let's say, like similar process, but thanks to like mostly like real-time rendering engine, there is now the ability to change the world itself. So the gods are still producing the world, but the world this time is alive. It can be through the interaction with the players, it's changing. And a good example of this is like World of Warcraft or Twitter. The players, though, still don't have access to the core functioning of the world. They are still outside the god's room. The third one is, I think, Dark Forest and
I wouldn't say Dark Forest. I mean, yeah, Dark Forest probably. We don't know what to put there, really, I would say. I think, like, you explain. No, I think you should explain.
Man, you always make me do the hard work. So the third one, let's say that this time the players are in the same room as the gods, so potentially they have access to the changing the world itself. The world itself has agency over itself. Yeah, sorry, I said itself 200 times. Is that it?
I think that's good.
There's more, yeah.
You should say like it's perfect. This is
yes, right. It's very perfect. No, I mean this is like definitely the model that we are interested in, and it seems like it's solving a lot of solutions. So we thought it's definitely that's the way to go. Everything is gonna be smooth, but of course no, it's not smooth. We did when we started developing the game, we did find some interesting questions we need to answer, especially when we produce. Well, especially producing like an open-ended narrative game. So for now, there's gonna be more, I'm sure. But for now, we have 3 questions that we are trying to answer.
Yeah, there are 3 problems that have arise from the process of trying to build an autonomous world, especially under the assumption of like player agency, which is a paradox in itself somehow. And we've outlined 3 problems and kind of are proposing at least our solutions to it, or poking at solutions to it. The first is the input complexity problem, which is that if Dark Forest and 0x Monaco, in our opinion, are maybe the best kind of examples of what on-chain gaming can be, because they allow creative permissionless input to solve problems. We don't really make all players gods, we make Solidity devs gods, which, I mean, good for all of you that are Solidity devs. I am not one. So this is like an interesting problem to poke around with. But what's nice is that there are games that actually have creative input through visual editors as an interesting game mode. And we think that there is a lot to learn from here. Factorio on the left and Opus Magnum on the right by Zachtronics are both systems that imitate fairly complex like construction models through a visual editor. And we think that leaning into this kind of domain could allow lowering the barrier to entry for creative inputs to more casual gamers, I would say. Yeah, that's the first problem. The second problem is the rule definition problem. If we want a world with full agency, and we want players to define the rules of the world itself, who establishes the initial rules, and why do people care? Like, why do I care about a world which has no narrative? Why do I care about a world where I can change the rules arbitrarily? And there's a paradox: if anyone can change the rules, no one can establish anything, because everything is up in constant kind of flux, right? So we are designing this in the way that you start with a single agent that you can program, similar to early artificial life games like Technosphere, or as they're called, ecosystem simulations. And then over time, as you kind of scale up in like organizational size or in group size or in governance, you get more and more agency over the world. So the game itself is the governance over the world. And by winning the game or going further in the game, you get more and more governance over the world. That's a way for us to kind of structure a linear progression of agency, setting up the rule set initially, and then allowing players to explore as they kind of experience the world, explore it, and a bit more and more agency over time. This mirrors kind of the progressive decentralization thesis that was popular many years ago in the space, but we think it's a good fit for potentially building on-chain games. We also think that in terms of narrative, there will be the need for a strong establishing narrative that is connected through the rule set. I mean, if we look at something like Twilight, it's very clear that like if a narrative is evocative enough, you can't actually prevent people from participating in it. It's impossible. Like even if we have like a closed world like Twilight, people spend thousands of hours writing fan fiction about it and participate in that world because they feel so strongly about the narrative. So it's super important to have a foundational narrative. But how do we make that narrative open? Well, our approach is that we separate the narrative and the mechanisms of the world into interface layer and on-chain layer, so that anyone later can build their own narrative window into the world, while us being able to still kind of provide a strong narrative angle into the world in the first establishment of the game. Okay, this is a tough one, and also a most exciting one to us. We're kind of presenting it as a problem, but it's more of an interesting narrative kind of angle, which is that if you have a world that anyone can change, how do you cope with the possibility of them ending the world at some point? And Ultima Online, the famous example of the ecosystem collapse, where they established this great ecosystem, there went a lot of planning into it, and then very quickly, the players just killed all the animals, right? And the game devs panicked, reverted, and kind of set protections around the animals. What they should have done is just said, yeah, they killed all the animals, now this is a world without animals. You know, you accept the kind of horrors that the players do to the world as the lore, and you base your narrative around it. And there are games that do this really well. Both Dwarf Fortress and RimWorld really lean into this kind of logic. Dwarf Fortress even frames itself as a narrative generator where the death of a colony is not a fail state, but a tragic narrative, or something like that, because I don't have the notes. But, yeah, so we are going to really embrace this, that the narrative comes from the player actions themselves.
Right, and as a quick note, since we use the world three-body problem, which we absolutely did not copy from the famous sci-fi book, it's interesting. In that book, there's, you know, scientists are playing a game, and like where they have to solve this very complex problem to keep the world of the game alive, and they fuck up, and every time the world is like civilization number X died after this and this and this, and this player managed to invent this and that. And I think that's a really nice approach, like this idea that the world is going to end, and that is going to build the next iteration of it.
Okay, so back to the game.
So back to the game. So that's, again, like our definition. But what does it practically means? Well, we kind of already explained it a bit, but what we imagine this game to be is basically that you will control an NPC. Maybe you can turn the slide. Yeah. You will start with an NPC that you will be able to program. And then like you can program a lot of like some actions that this NPC is going to do in the world. And then you're going to throw the NPC in the world and see what happens to it. And obviously, there are many things that can go wrong. So the beginning of the game is basically going to be about survival. It's on the individual level. You control one NPC, and you will try to survive in this world. There's resources you can farm, and you know, stay alive. It's some sort of Rust-like environment. And then, as you proceed with the game, you will be able to create more and more complex operations that you can do, and more complex social structures. And this will allow you to unlock different type of gameplays. And eventually, if you spend enough time in the game, or if you're good enough at the game, you will be able to reach the world scale and potentially basically take over the role of game developer.
Yeah, I mean, at this point, this is a very ambitious project. We're aware of that. So we're going to start in the first part down here. Our first prototype is down here, and we're going to see and fail probably a bit, and then learn from that and then build out in this direction. But we think that this arc and this logic is very promising in kind of thinking about what on-chain games can be as a kind of casual experience that has social forms be the medium for how you get agency over the world itself. And our first wireframe, this is a horrible sketch. But it
Well, it's
shows.
not horrible because Rasmus made it and it's great.
Okay,
but
it's
he told
amazing.
us to absolutely not show it, and that is why it's on the screen.
I mean, but we felt like it would be good to show something that kind of points towards what an early prototype could look like. And here you basically have an NPC, you have a certain amount of resources, and you can basically sequence a behavior by drag and dropping operations from the right side. If you want to write your own operations that interact with the resource logic of the world, you can do that. We also want to have something similar to the Dark Forest plugin logic that then custom operations kind of repopulate in the front end of other players. And on the right side, you kind of, every time you come back, there is a log, there is a narrative that has been generated when your character has interacted, your NPC has interacted with the world independently. And that might be, you know, it has died because it didn't find food, or it has, you know, yeah, whatever it is. Is that it?
Basically, it, yeah.
Yeah, so we end up where we started. We hope this has been a somewhat interesting exploration of some of the tensions of agency within the idea of autonomous worlds. Kind of our poking at some of the solutions that we find have potential for this. And our goal is to have a prototype by December, January, yeah, that you all can fail in. Thank you.
Thanks.
Check, check. All right. We're very far ahead on the schedule over there. Before I continue talking, maybe just another quick round of applause for everybody who presented in the last little bit. Thank you, guys. Yeah, so we're going to stick with our schedule because we don't want to, you know, for people who are planning on showing up on these times, we don't want to push anything up and mess with that. So it's kind of an early break. We're at the lunch break super early. It's like 11:10 or something like that. But I was just talking to Justin, and he was saying, you know, if any of the presentations or the demos you just saw were interesting to you, kind of the whole crew of people who just made those presentations is right there in the corner hanging out. So we are going to break, but mingle, talk to the different folks on the team, and we will come back at 1 o'clock for the Frontier of Autonomous Worlds panel. So yes, thank you guys for coming out. I know it's the last day of the conference, and maybe some of you guys were out late or just tired from a full week. So thanks for coming to a morning session on the first day. And we'll see everybody formally back here at 1. But yeah, feel free to meet the team and mingle and get yourself some food and coffee. And we'll see you then. Cheers. Hello, check, check. Hello, awesome. Mic check 1. Mic check 2. Brian, you want to do a little, or Gupsheep, do a little mic check? This one works. This one works.
Oh, okay, we're good now.
Excellent. You guys will share this one. Test. Hello, everybody. Thank you for coming back for round 2 of the AW self-lit sessions. If you were here with us in the morning, thanks for coming back for the afternoon. If you're just joining us, welcome. We're going to kick it off with our panel discussion. I'm really quickly going to introduce our 2 moderators, our co-moderators. We have Ayush and 0x Hank. They are going to give a quick little opening remarks, introduce you to our panel, and then we're going to get started. So let's give a round of applause for our co-hosts.
So today's panel is called Frontiers of Autonomous Worlds. Now, the frontier of autonomous worlds, maybe 3 years ago, didn't really exist until Dark Forest happened. And it was largely the same for a couple of years until now, when there's been a huge explosion in what we can do with these technologies. And so we want to ask a lot of questions about what is coming forward and how can we predict what's coming next.
Yeah, the frontier is looking bright, and I think we're all excited to see what's coming. But it's also somewhat unknown. A lot of this technology is really nascent, and it's unclear what it's going to look like in even 2 or 3 years, let alone 5 or 10. So we really want to push you guys today, uncover your long-term visions as well as what's just been going on recently. So why don't we start by introducing everybody. Let's start with Gupsheep and then work our way down.
Hey folks, I'm Gupsheep. I work with 0x Park. I spent a lot of time from 2019 to 2021 building out a game called Dark Forest with a handful of friends, some of whom are at Devcon as well. And these days, I mostly think about applied ZK R&D with 0x Park groups.
Hello, I'm Kevin, part of the founding team of Optimism, building the Optimism Collective. And nowadays, I spend most of my time thinking about how to build the next version of Optimism mainnet, which is called Bedrock, and then how we extend that to the OP stack to empower autonomous worlds.
Hello, everyone. I'm Alvarius, and together with Justin, I started Lattice 18 months ago approximately. We started building a specific on-chain game at first, but then ran into a bunch of very general problems. And so we decided to build a key missing piece of infrastructure, a game engine for autonomous worlds at the beginning of this year approximately. And that was my main focus since then.
Cool. Hey, my name is Justin. Approximately like 2 years ago, I ended up in Mexico with Gupsheep working on Dark Forest. And then from that, we kind of like started 0x Park together with another friend. I was working on an on-chain game with this gentleman. It was really hard. We gave up. We started again, we gave up again, and then we were like, okay, we have to solve some like fundamental problems first. So we hid in a cave for a long time. We built a team, we wrote essays, we wrote mud, and now we're out of our cave with cool stuff.
Awesome. So maybe to start understanding what the frontier is, it would be good to go all the way back to the beginning, to 2019, when the frontier was Dark Forest. And I guess what lessons can we learn from that era that could possibly be used now to understand what's going on?
I can maybe kick things
Yeah,
off.
Gupsheep.
I can kick things off, and I'm actually curious to toss it over to folks because I think that honestly, like the 3 of you on stage right now have been thinking much more deeply about this. Back in 2019, and I mentioned this a little bit in a talk I gave earlier this week, I think that the idea of like a fully on-chain game that was more than like an NFT collectible game didn't necessarily seem like it was like technologically feasible or like worth exploring. And I think the takeaway from this probably shouldn't, I mean, like, there's one takeaway which was like, oh, you know, like in retrospect, like this makes sense as an area of exploration and we should pursue it. But I think that the like slightly more interesting thing to think about is like what kinds of things 3 years out from now, like let's say it's 2025 and we're having this panel and we're like asking about like mud in 2022, what things can we try today that seem like unreasonable or like purely just like intellectual explorations that we don't know where they're going to go, we don't know if they're going to be feasible. I think just like keeping them in the spirit of like exploration and play is really important. Maybe on like a more concrete note, one of the things that has been one of the biggest takeaways for me from the last couple of years is this idea of like emergence, I guess, like this idea of like you build the substrate for then the community to build itself. And I'm actually curious to hear about like, I mean, you know, I'm sure that there's a lot of really interesting stuff going on in Optimism that's like unpredictable, and even in the first couple weeks of Mud being live, I'm very curious to hear.
Yeah, I mean, I feel like from 2020, 2021, like I remember we spent a lot of time talking about like, can Dark Forest run on an optimistic rollup? And at the time, it was just too expensive. Like, we kept like brainstorming. We're like, oh, can we make it work? Are there ways that we can like, oh, we'd have to like spin up a brand new chain, and we were still working on Optimism mainnet and getting it to a point where like it was production ready. And I feel like we're finally at a stage now where the way we've constructed Optimism mainnet can be easily repurposed to spin up not just like one game chain for Dark Forest, but just like hundreds or thousands of chains very, very easily. So I'm excited that like, I feel like we're finally at a place where like, can we run Dark Forest on a rollup? And the answer is gonna be yes, very, very, very soon.
Cool. Hi. Yeah, I mean, when, like, I mean, you folks had been working on Dark Forest for 2 years. When we started doing stuff, it was also very hard. I think the main thing that people are missing is not necessarily the tools and the technology, but the mental models. I think that when you kind of like, so again, you come from DeFi, like hyper optimization, surfaces for auditability, and then try to build something like Dark Forest. Well, what you do is like, you make one step forward, but you still kind of like keep the infrastructure you've seen before. So like the Dark Forest contracts look like DeFi contracts. The difference is that they're not gas efficient and not audited and like way more crazy. And like fast forward to now, I think that from the perspective of like the Ethereum protocol and Solidity, not much changed, but something like Mud, where we sat down and decided to give up all constraints and like think about a novel architecture. That's actually one of the things that like pushes the envelope forward. And it's interesting how it's all of those different dimensions, and like you need to get all of your cards right in order to be able to like create a product that is like a step function advancement compared to the things before. So I think that right now what we're seeing is better toolings, better models, and better scaling solutions will probably like bring us to like kind of like a different era.
So continuing on, just thinking about what has already come, what are the lessons that we could learn from things like Dark Forest, some of the really new builds on top of Mud like Sky Strife, the new game, and OP Craft, which is kind of like the tech demo game. Are there any properties of those worlds that we could see carrying forward as these worlds get more complicated and get more interesting and more alive?
So I think that one thing I'd like to say is that like Ethereum mainnet is the best MMO right now, but it only caters to like a very specific type of people. And what we realize is that, I mean, what everybody's realizing is you can have a very simple set of rules plus like some observability into the system and autonomy, and then you get crazy emergent behaviors to happen. Like things like MEV it's an emergent property of like a public block market. And so, yeah, like I'm curious what you think, Gupshi, but from Dark Forest, the thing that was interesting is like focusing on making a game with like the simplest possible like layer of rules, and then leaving obvious space for the community to build things, and like farming the emergence from there, I guess.
Yeah, actually, I can talk a little bit about some of the like design decisions that went into the like initial versions of Dark Forest. I still have all these like old spreadsheets with like, you know, a bunch of formulas that eventually made their way into the Dark Forest smart contracts. I think that Alvarius and Justin have been talking a lot about this idea of digital physics, and though we didn't really have like a great like term for this at the time, I think that actually captures very well like the intuition behind what we felt might make for a viable on-chain game. Because the chain is such an adversarial environment, you know, like Justin said, Ethereum is this massive MMO where pretty much like anything goes. It's like, you know, anarchy out there. The way that we tried to design Dark Forest from the beginning was, well, there was a few principles. For example, one was scale invariance, which is kind of another way of saying like Sybil resistance. So because you have because you have this world where you can't like, we don't want to like KYC or something every player coming onto Dark Forest. It should be the case that like, you know, having 3 accounts playing Dark Forest should not give you more of an advantage than having one account that's playing at 3x the scale. So if you've played Dark Forest, you'll notice that like, there's this continual geometric progression where you start off at like a level 0 planet, and then every planet level up on the hierarchy gets 4 times more rare, but also like approximately 4 times more like strong or powerful. And this is something then that like gives the game almost this like sense of physics around like what is the maximum like rate of resource harvesting that you can get, like what is the maximum speed of light was also another question here that we tried to tune around, like basically the maximum speed of movement in the game is another thing that we tried to tune around the relative planet sizings and like what are the scales that different players are going to be playing at. So I think thinking about things from like this really like grounded like first principles physics level, which is kind of a, like I know that like some folks in like traditional game design might like want to, really push back against that. But at least for getting something on the board, that was I think a good choice for us.
Yeah, because usually you have like a player promise. You're like, I want the players to feel this way, and then you reverse engineer the rules from the player promise. And here it's more like, hey, here's a world that is kind of okay, like it self-regulates, and we don't promise you anything. And I think I remember there is someone who texted me on Discord back when one of the Dark Forest run was running, saying that that was the coolest thing they had ever done on the internet because everything was emergent essentially.
Yeah, for sure.
Yeah, and I mean that's kind of also one of the base principles we put into OPCraft, where it's, in case you haven't seen it yet, it's like an on-chain voxel game that kind of looks like Minecraft, but is not really Minecraft. And that's exactly the thing you have to keep in mind. Like if you think of this as Minecraft, then it's just a shitty Minecraft because it doesn't have the same features, it doesn't have like the same, basically people can just send transactions directly, and there's some things that are not enforced in the physics. But instead we wanted to make the physics very simple, such that other things can be built on top of that. Like speaking of this emergent behavior. And yeah, we just launched that, basically soft launched it on Wednesday, and we're very curious to see what people actually come up with.
Yeah, I'm really also curious to see what people come up with. One thing I'm wondering about is this digital physics idea is so cool and new, and what is stopping people right now from experimenting and building on top of these primitives?
Yeah, I mean, I think a big thing up till now has really just been the tooling. And this is where I think like, MUD and the particular infrastructure that Kevin mentioned for being able to like launch game-specific plasma chains is so important. Every single feature that we added to Dark Forest was really like we were fighting an uphill battle. Like we would have to thread like, I mean, Andy spent a lot of the last like, the like first 6 months of this year. It was just like, it would take a month to add in this feature of like spaceships, which should be this really simple thing if you're working with like Unity or Unreal Engine. Here you've got to go through, you've got to like wire this through like the contracts, the ZK snarks, like the interface to the client, the various different like open source packages. There was no game engine, and so every single feature was just this like ad hoc thing that you were, writing like over like 5,000 lines of code to like introduce like a new item into the game. So I think it's just, one of these barriers is just developer experience.
Yeah, I mean that's exactly what we went through when we started working on an on-chain game beginning of last year, and we basically spent like 5 months or something building the core physics, and then we play tested for the first couple of times, and we realized it's actually not that fun, and so we wanted to add some content. But then adding content would have meant refactoring the entire code base and like editing like hundreds of files to just add one new type of entity. And that's exactly why, and like with which in mind we built MUD. And now with MUD, Andy was able to build the first version of SkyStrife in like 2 weeks and was able to play test then and then continuously iterate over it to make it much more fun.
Yeah, I think like, just to add on to that, like one of the crazy things when I look at the difference between something like SkyStrife and Dark Forest is the level of complexity and the amount of content. Dark Forest essentially has like 5 types of entities in it total. There's like planets, there's, I guess like 2 types of resources, energy and silver, and then there's spaceships. I guess there might be four types of entities really in Dark Forest. And in SkyStrife, there's like, over a dozen units, like a bunch of different kinds of buildings, like multiple dozen like kinds of relations or interactions that you can have between these things.
Cool. I kind of want to start pushing you guys a little bit. Obviously, we call MUD Autonomous Worlds game engine, and autonomy is a huge part of it. Kind of on the other end of the spectrum, we have this company called Meta, which is kind of building like uber centralized worlds. And so I'm curious, and I'm sure other people out there are curious as well, really, why is autonomy so important for these worlds? What does it bring that Zuckerberg will never bring to the table?
Yeah, so one way I think about this is there's this book called Emissary's Guide to Worlding, and it kind of like looks at, okay, so if you want to build a world that is alive, and they define aliveness as the inverse of the time that the creator needs to put into the world to keep making it cool, right? Like, as an example, Ethereum, actually, Bitcoin is maximally alive because Satoshi is not contributing anymore. Ethereum is not maximally alive yet. We still have like some of the creators that have a lot of power, like still pushing for stuff. And one thing that is interesting with autonomy is that you unlock actually like a total different kind of relationship with the thing than with something that is not autonomous. So maybe one way to think about it is, if a world is autonomous, essentially it's gonna bring essentially different kind of affordances, and people are going to relate with them in a different ways. So to kind of like compare it with Meta, basically, if you want to build an autonomous system that lasts for a long time, you need to essentially give up the mask of director. You can't say, hey, I know what is best for this world, therefore I will bring the thing that it needs to remain interesting, because that is essentially like shutting down pluralism. You have a single group of people that think they know what's best, and then you end up with like Marvel movies, and you end up with like all of those like things that are like maximally dead, basically, in terms of like from that perspective. On the other side, if you build a system that, one, has claims to autonomy, and two, has rules in such a way that like there is no difference between the people that add the content and the people that experience the world. Like, this reality is a great example. Like, I do not need to get a certificate from God to build a house. I just build my house, and nobody needs to tell me, hey, you can do that. But at the same time, the fact that we all have to comply to the same kind of like lower level rules means that we can live together. I think that one thing that is really crazy with all of those like metaverses, like Roblox, blah, 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 where like people can create different experiences, is that they're extremely lonely. They feel like theme parks. You move from one place to another, and essentially they're dead, right? So I think that, yeah, that's how I could count. But also it's a bit like a mystical answer, so maybe not the best, but I'm also curious what other people think. And I think, Kevin, you also think about autonomy a lot, right? From the perspective of building those things that need to be, like, live on their own.
For sure, yeah. I feel like autonomy is actually really important, like also layered down in terms of like building the actual chains and the infrastructure. So I think like a couple years ago when Gupsheep and I were talking about like, can we run a dark forest chain? It was like, well, we'd probably have to spin up a new chain with different parameters. It'd probably have to like, maybe we'd have to swap out the data availability layer. And we were such a small team at the time, it's like, oh my God, we're gonna need to hire like 2 more DevOps people. We're gonna need to like have a brand new product. Like, this is gonna be so much effort. But I think the big realization we had is like, right now, a lot of blockchain companies are like, currently they're trying to like build the infrastructure for like app chains, for app specific chains, but you have to go to them and like ask them to go spin it up for you. Like, you have to be like, hey, like X or Y company, can you please spin up a chain with these parameters for me? And then you probably have to pay them a bunch of money, and like you also don't have autonomy over like the infrastructure that you're building on top of. And I think one of the big realizations that I think Lattice really opened us up to was like, without us even like talking to you guys already had like forked Bedrock and we're running your own chains, and like because we have an MIT license, because we designed it in this modular way where it's like maximally simple, you guys were already like autonomously taking this infrastructure and spinning it up for your use case. And yeah, despite like you guys spun up a testnet before we had a testnet running for Bedrock. Like, I don't know how you did it. You guys are insane. But yeah, I think what we've realized is like, if we design the software stack for these chains in a way that is maximally modular and maximally simple, that like any chain can just go and like any app can go and like take this infra and spin it up in their own way, have full autonomy, decide what their gas limit is, decide what their data availability layer is, decide what their proof is, decide what their VM is. And I feel like that unlocks just like, that will unlock just this, I don't know, Cambrian explosion of just like apps that cannot exist on chains that that currently exist, and like it removes the barrier of entry from like needing to go create a partnership with one of these blockchain companies to spin up a chain for you, and like you can just like go do it yourself, Yeah.
I want to also give maybe another angle on why I think autonomy is important, just from like some empirical observations that we saw with like the Dark Forest community. One cool thing that autonomy does is that like when you see an autonomous system, that autonomy is almost a credible claim to the system's longevity. So like, what does that mean? Well, concretely, you know, Dark Forest would run in these like super ad hoc rounds that would be like, you know, every couple of months we would just like drop like a week-long Dark Forest round. And we'd have these like fantastic periods and bursts of activity like during the week of the round and like the week right after. But then, you know, afterwards there wasn't really any like credible commitment that was made by like the core dev team or the system that this world would continue running and being alive and being interesting. And so we had a bunch of these players who were kind of like stuck in this weird middle zone where they're like, oh, I'm like interested to build more stuff on this, but I'm just like not sure if it's worth it because I have no idea if the next round's gonna be like 6 months out, a year out, if it's even gonna be like the same thing, or if Dark Forest will even continue at all. Whereas when I look at like, you know, the third-party developer environments of games like EVE Online or RuneScape, which are also not entirely autonomous worlds, but have a sufficient amount of like player, ground-up, bottom-up activity, you sort of know like RuneScape is going to be around in 2.5 years. So you like spending a weekend or like committing the next 3 months of weekends that you have to committing to like the RuneLite open source client is like a worthwhile endeavor for you because it actually is being woven into this like fabric that's going to continue onwards.
Yeah, and just one more thought to add is basically if you want to have a world that's interesting enough for people to believe in, then it's of course much more much easier to create that if there's many people contributing to it, right? Like if there's only Facebook building this like metaverse, then it sounds kind of boring. And it's the way I think about it is like the parallel between a planned economy and a free market. Where in a planned economy, somebody controls everything, and usually it's not the best outcome. Whereas in a free market, everybody can contribute to it, and then the outcome is usually much better and much more interesting.
So while these autonomous worlds are very interesting, it seems that current infrastructure like the L1 mainnet is not really possible to run these autonomous worlds on. And so if we really want to unlock like the infrastructure layer that can support these autonomous worlds, like what are the changes that need to be made and what are the technologies that we can look forward to for say a 100,000 person MMO or even bigger?
Yeah. I think like the first step is like making it incredibly easy to spin up your own chain, right? And I think like we definitely vastly underestimate like what it means to spin up a chain. Like there's so many components external to the chain itself that people now just assume is part of a chain. Like a chain is not actually live until you have a good block explorer. Like you can't actually like if you give someone an RPC endpoint for like a node, it's like, oh yeah, here's a chain, like nobody's gonna know what to do with it. And people are like, oh well, where's the explorer? Like this is a very fundamental piece of like what makes a chain today. And I think there's all sorts of other pieces of infrastructure like that, like having an AMM, having like Gnosis safe. Like I think we would start to expect that like any autonomous world would, you know, it would be really helpful for the builders in that world to know that they have these basic primitives that they're used to in the Ethereum L1 MMO. So I think like the vision with the OP stack, and like we're not there yet, is like literally just being able to instantly spin up a chain that has all of these components, right? You spin up a chain, it automatically has a hosted block explorer, it has a hosted bridge where you can like bridge tokens in NFTs in and out. It has an AMM already launched with the front end. It has, you know, Gnosis safe and maybe even like Tenderly, maybe even it comes with like, you know, a few extra infra providers like Infura or Alchemy. Yeah, exactly. So I feel like that's what we need to be able to enable like thousands of chains, and like the scale that you guys need for like these autonomous worlds will require like thousands of chains, you know?
Yeah, so that's step one.
Yes.
Step two is you have to go even more degen, and basically, I think that right now, kind of like the assumption is, hey, we need like atomic composability between everything. Like every contract should be able to call another contract like within the same synchronous call. But I think that kind of like that assumption breaks down if you think about embodiment. Like in this universe, I cannot actually like impact Alpha Centauri right now. I have to wait a couple minutes, even if like travel at the speed of light. So if you bring embodiment in some form of like, essentially like, I mean, it's like a symmetry. It's like you have like a maximum speed limit. You can start sharding things geographically, and Carl gave a talk about this, about the superchain. If you have a shared set of sequencers, then you just have a single block delay when you pass from one to another. And so there's this great talk from like the Geth team lead about the limit of physics in Geth. Like you can't go faster than 1 billion gas per second for too long, because otherwise you're literally gonna hit the limits of computers because of the data structures. What you can do is you can have many of these running in parallel, and true, you break composability between them, but if you make everything embodied, it doesn't actually matter. So the other kind of like interesting side effects from this is markets are gonna become extremely inefficient because there is no such thing as a global market. And I think that that's gonna be quite fun and interesting. It's gonna level up the MEV game. Yeah, it's gonna be insane. Like, the MEV bots of the future are going to be the industrialists of autonomous wars. They're going to build trains and stuff like that, just like move resources fast and do arbitrage. So I think it's kind of interesting if you go away from the use cases of like extremely efficient DeFi markets and like really composable like NFT primitives, everything goes, right? It's kind of like this new scene that unlocks a design space and ideas that people left on the floor and like didn't bother picking them up anymore because they didn't cater to like the existing market. So I'm pretty excited to just be able to do like stuff that wasn't done before because nobody needed it.
So one note on the composability is that so far we've only talked about games existing in their individual silos. But it seems that if everything's built on a shared infrastructure, then there might be interoperability between these games. I'm curious what you guys think that looks like in the future and how the things that you're building might enable that.
So this is, again, one of the like key principles that we put into MUT is like interoperability between all the different games. If you build MUT, and I'm later today, I'm going to give a talk about MUT in case you're not familiar with it. But in just a few sentences, there's components and there's systems that are registered on a central world, and there can be multiple games actually on the same world, or multiple layers of augmented reality basically on the same world. And then the clients decide which components and which systems they want to interact with. And that's kind of already one like level of interoperability, like different games within the same game, right? But then at the same time, different worlds are also interoperable with each other because they all use the same like way of storing the data. So the way you query your own world is exactly the same way you could query any other world. Yeah, and basically you can read from anything and you can only write to the things that you have access to. And yeah, what people will come up with it, I don't know. We're just here to build the infrastructure and to enable people. But yeah, I'm very curious.
I have like one super quick note for this. So I think that like interoperability, like the naive way of thinking about it makes no sense. Like what does it mean to bring a Lamborghini in World of Warcraft? Like that's just like super dumb. Like the only thing that actually can go like from one place to another context-free is identity, money, and reputation. Because those things are actually like truly general enough, like from our like kind of like subjective experience that we can bring them to other places. Yeah, as Alvarez said, I think like interoperability within the same world is going to be quite important. The same way like in this world, like you can drive and you play tennis, and those are like completely different rules and like kind of like shared hallucination we have on top of the world, and that works. But like, let's say we have the multiverse, and like I bring my Lambo to like a place that has like 4 dimensions. Like, what does that even mean? So I think that this thesis of interoperability between like different games, actually, it's like a bit silly to me. But things within the same world where like some core team brings very low-level rules that don't even include things like capitalism and competition and stuff like that, and you have other people that brings that. I think that's the thing that I'm actually really excited about. And that's what we're already seeing with Ethereum mainnet, right? We have interoperability between the things that have the same kind of like platonic class, you know, like money or like identity or stuff like that. If you go beyond that, it's just very silly, in my opinion.
Oh, I mean, you know, I think that's a great point, and it makes me think about like, you know, for example, the phrase or like the term NFT is used to refer to like a bunch of different classes of things. One thing that it is used to refer to like specifically is, you know, digital art ownership rights, for whatever definition of ownership you might care about. Another might be like, you know, a representation of a position on some, you know, decentralized exchange or marketplace or anything else. And like, you end up with like a lot of problems when you like try to like mix these classes, and you have to be like very intentional and deliberate about like exactly like what terminology and what mental model you're building around like what is an, you know, an NFT.
Yeah, I mean, ultimately it's just a claim to ownership, right? And ownership doesn't interoperate that well.
Yeah, so Justin, you just said that there are only really a few things that need to be interoperable. And I kind of want to ask about that on the canonical side as well. How much do we really need to rely on a blockchain for, let's say, in Dark Forest, every time you do anything, it goes straight onto the mainnet of that blockchain. So, and I think we've seen with OPCraft that you can actually maybe start to move a little bit further away from blockchain to other decentralized technologies in order to get functionality that isn't necessarily intrinsic to the, like, who wins the game. So how much can we stray from blockchain in order to kind of unlock some of these interesting features versus how much do we really need to be always canonical and immutable?
Yeah, before letting my friends answer, just a little context in OPCraft so people kind of understand the question. In OPCraft, breaking a block, dropping a block, crafting something, inventories, all of those are verified on EVM. But one thing that the chain is not aware of is where you are. So this was like we did this on purpose. We had a version of OPCraft where position was on chain and like you could do things only in the chunk around you. You had to provide like some form of like A-star proof that you were moving according to the right way. Anyway, the reason we didn't do this is because it was like a social experiment. And so what Xerox Hank is referring to is that when you play OPCraft, you can see how the players go around and run around, but that is actually not going through the chain. It's going through a peer-to-peer layer. So yeah, we have like those kind of like two different kind of hardness in like George Stark term. And yeah, I mean, I'm sure you two thought about this. So I mean, even Kevin, today, the thing that is crazy is like, if you look at like OpenSea, there's a lot of things that is actually just like derived state from what is actually on chain, and like the kind of like the design principle of all of those apps is like put the least amount of things on chain possible, which breaks composability, but like brings scaling. So as example, smart contracts can't buy NFTs on OpenSea. And so you always have this kind of like trade-off, like when can humans participate? When can like autonomous agents participate?
Yeah, I mean, so to put it simply, a blockchain is basically just a consensus engine, right? So if you wanna, if it's important that one transaction is, like if the order of the transactions, for example, is important, or if the physics are somehow enforced in the game rules, then of course it would have to be on a blockchain. And even if we didn't have blockchain and we wanted to build something to enable that kind of stuff, then probably we would end up at a blockchain in the end. And yeah, for OPCraft, some of the things that just make it nicer for people, like you see where other people are, you see them moving around, you see where they look and what block they have in their hand. Stuff like that, it's not relevant for the game or like for the physics, and that's why we decided to not put it on a chain, but rather on a like signed message layer.
Oh yeah, actually, so we had a really early experiment with this in Dark Force as well, where like if you owned a planet, you could like put a little like emoji flag on top of it, and that was not something that was stored on chain. It was actually like I mean, we could have put it on chain. It actually might have been slightly simpler too, but we designed a pathway for that to end up being stored on a web server, the same web server that also stores the mapping between like addresses and Twitter handles. And the reason there was we wanted to start opening up a pathway to have like these auxiliary gameplay elements that did not, like, even if people were adversarially oriented towards those gameplay elements, the underlying game mechanics themselves would still function, and the idea of, you know, who is like winning the game or who has X amount of resources, that stuff is really important to come to consensus on. But if, for example, like the, you know, Twitter address mapping goes down, or like the emoji, you know, planet mapping goes down, like that's not a huge deal, but it actually does add another layer of interestingness to the game because people can use those as communication channels.
Yeah, actually one more thought to add on that is also in OPCraft we have the like a linking between the address and Twitter, and now we wanted to also show that in the game, but we didn't have it on chain yet. And then we thought about how to do it, and we could have written a like custom like integration with a server that's already storing the like Twitter username to address mapping. But it turned out that it was actually easier and much more straightforward to put it on chain and put it in mud, and then we could use the like infrastructure that was already there to just like use it, yeah, in the client. With like it was just so much easier that we ended up doing it anyway, even though it's not relevant for the physics.
It is a centralized oracle that just say like this is that.
I also think we might have to add nuance to the term like on chain, right? Like as it becomes easier to spin up like all these different chains, like you can have an incredibly degen chain that just like hosts data in an AWS server and like has 1,000x Ethereum's throughput. And you can also have like a chain that's as secure as Optimism mainnet. And so like on-chain can mean very different things. So maybe like player position is less critical and goes in one of these, you know, hyper degen chains, and like, sure, maybe like you lose some data along the way, or it's really hard to run a node that like actually, you know, calculates everyone's position. But like, I feel like you can have like secure on-chain, you know, gameplay transactions, like insecure on-chain transactions, and like with the superchain, I feel like there will be this design space of like, okay, like maybe this user travels to this planet and now they're in this degen chain, and like they can send a crazy amount of transactions and it's super insecure, but they opt into it and they know they're in the Wild West here, but then they like fly back to this other chain where now they're in a safe place where they hold all their money, and like, you know, this is the secure planet, you know.
Still better than the meta server, even if it's like super degen, but yeah, that's a good point.
I have one more thing to add on this. This is another example, actually, of a thing that I know like folks thinking about blockchain infrastructure have talked about a lot previously, which are, even if you don't have a consensus engine, there's actually still a fair amount of security that you have through the usage, like through the correct usage of cryptographic primitives. So for example, like one thing that, you know, despite the fact that the Dark Forest admin server stores and provides sort of as an optional service this like Twitter to address mapping, we still like attach to all of those key value pairs a signature from the Ethereum account that this is indeed their Twitter handle, and a verified tweet that tweets out that signature, so that, you know, linking can go both ways. And we can't forge that. Like, we can't convince you that this address is connected to this Twitter account if they haven't done that signature. So there's still a cryptographic guarantee there. I think the thing that you know, blockchains really provide is data availability at the end of the day, and that's, you know, sort of what we've realized over the last couple of years. So again, like, you need to distinguish between all these different notions of security. There's like, you know, questions about like correctness and forgeability. There's also questions around like data availability and censorship, and these are all like different dimensions. And so it's not just a one-dimensional trade-off curve either. It's multidimensional.
That is interesting to think about. Like, as new cryptographic primitives emerge, new on-chain gaming or autonomous world ideas also emerge. In a similar way, as new infrastructure emerges or new chain primitives emerge, we'll see new things that are able to happen. So I'm curious, like, over the next 5 or 10 years, what are like certain new ideas or primitives that you're excited to see happen, and how might those change how autonomous worlds operate?
Yeah, I can start on this one. So me and Justin did a little like lightning talk kind of thing in the hacker basement a couple of days ago, where we speculated about how some new primitives might enable new mechanics. I'm personally pretty interested in how like primitives like fully homomorphic encryption or multi-party computation or witness encryption, these things that are like, you know, even stronger cryptographic primitives than what we have today, that are still sort of at the academic level, but hopefully going to productionalize over time, what that might unlock. So to give an example, a lot of folks here might be familiar with this idea that ZK enables you to now put hidden state into games. And this is a powerful primitive because previously you might not have been able to build like a card game where people's cards were private on-chain, but now with ZK you can. One thing that you still can't do, though, in terms of incomplete information games, is you can't have games where there's interactions between mutually distrusting parties who are trying to compute jointly over like mutually private state. Okay, so what does that mean? Like, maybe, you know, I have an attack coming from like a secret unit on my side, and I'm attacking, you know, Kevin, who has like a secret defender, and we want to figure out what's the overall like net impact of this attack on Kevin's health. Well, we can't do that right now because I want to keep my attacking forces private. Kevin wants to keep his like defending like special defense, you know, stats or power or whatever private. So that's still something that's not possible with ZK, but with MPC it might become possible.
I'm hyped about 1 million TPS. By dropping a bunch of stuff and cutting corners and like going zoom zoom. I think it's going to be really interesting. One thing I wanted to add to the last question, 10 seconds, is that even a centralized EVM server is extremely interesting because the EVM is a computer that is made for like atomic composability and also observability into the system itself. And like, even if you were to build World of Warcraft today on a centralized EVM, that would be like pretty fucking sick. So this is why, like, to go back to Kevin's point, like, even if maybe we should say on EVM, off EVM, instead of on-chain, off-chain, but I mean, this spectrum is going to be milked in so many directions because there's just a lot of stuff to do there.
I guess a real quick last note is, like, I feel like we live in a world now where, like, ERC20 tokens are obviously a very established primitive in blockchains, and I feel like there's all sorts of surrounding infrastructure around them, and I want to live in a world where, like, a blockchain itself is that same type of primitive. So one thing I was thinking on the way over here is, like, just like how in Uniswap there's, like, a token list, and, like, that defines, like, what are the list of, like, safe tokens that you want to trade, like, and you can have different levels of token lists that, like, CoinGecko has a token list that has, like, maybe more risky tokens than the Uniswap token list. You can have, like, a chain list, and it's like these are the chains that you feel safe interacting with, and, like, maybe you can have, like, a more risk tolerant chain list where, like, okay, I'm cool going to a place where, like, data availability is off chain. Like, that could be, you know, that could be something that you parameterize, and I think, like, I'm excited for, like, there to be all the surrounding infrastructure that exists currently for ERC20s as primitives. So, like, you know, maybe the CoinGecko, maybe there's, like, a CoinGecko for chains that lists, you know, what's their security, what's their current gas usage per second, you know? I'm excited for that future, yeah.
Can I actually pose a question here as well to the rest of the panelists? Because I feel like we've been throwing around a lot of terms, but some of them have been, like, imprecisely defined, at least where this conversation has been going. So we're talking about this world of, like, a lot of different chains, but as people have noted, chains means a lot of different things. For example, I think a thing that y'all are not meaning when you say this world with a bunch of different chains, many of which have different security guarantees, is like, oh, a world where we're, like, you know, bridging between, like, Solana and AVAX, and, like, you know, the multi-chain future is one where, like, you know, you take your soul and you go on to, like, EOS, and then you, like, bridge your NFT to Binance. Like, that's, like, not really, like, the vibe that I get here. So can you distinguish between these two notions of what multi-chain here means?
Yeah, I guess a quick note on here is, like, you should totally go, if you have not watched Carl's talk or Kelvin's talks on, like, the super chain or the OP stack, that'll go into way more detail. But I think the vision here is that you could have many chains that are all spun up using the same set of APIs, so, like, the same set of modules. So they might use different modules, they might use a different proof system, or they might use a different data availability layer, but they all use the same APIs. And if they're all built using the same shared language, the same stack, you can easily do things like have them share a sequencer set, which would allow you to do things like, if the sequencer set is honest, that you can have atomic composability between these chains. So rather than living in this world where, like, you have many different chains that are designed in their own different monolithic way, you can have all these different chains that are all designed in the same modular way and can all interoperate, you know, in ways where, like, as an end user, maybe I don't know what chain I'm on all the time. Maybe I just know that I'm on chains that are in the list of chains that I've, like, agreed, you know, I know that all the chains I interact with have data availability on Ethereum or something. And, like, as an end user, it feels like a single chain that I'm interacting with, but under the hood, there's actually many different chains, and you might actually just, like, if you're running a node, you're just running a node for one of those chains, you know?
Yeah, I guess the main difference between that and something like even like Cosmos that has like IBC and instant finality is that Cosmos has different validator sets depending on the different chains. So you can have like lower security zones, higher security zones. I think the thing that is really interesting is like even if we have rollups with like different data availability layer, different proof layers, as long as they all kind of like ultimately settle down on Ethereum mainnet, you have this amazing thing where like if something reorgs, everything reorgs. Or at least like if the layer one reorgs, everything reorgs, and you ultimately use Ethereum mainnet as like a global clock. And that, I think, is going to unlock way more than just like this super janky thing we have right now where, yeah, we can move money across, but the bridge gets under-collateralized and stuff like that. Like, that is going to be needed if you want to send rich messages across. So, yeah, rollups for the win.
All right, I think we're running out of time. I'm gonna throw one more question out there. So, it's really early. It's 2022, and I want to look forward far into the future, into the world where autonomous worlds are just a part of our daily life and everybody's interacting on autonomous worlds. And I guess, what is the ultimate vision and the ultimate promise that autonomous worlds can bring to people?
It's a scary question. I don't want to go first.
Sure. So personally, the way I think about it, also when I think about like the metaverse, is not that stuff that's currently happening in the real world would move there, but rather that it's like just a very interesting thing to experience, just like we experience regular games right now, or like movies, or other things, like other kinds of worlds that we currently experience. That's autonomous worlds on steroids, basically. So that's the way I think about it. So in what was the question?
Like, what's the promise that autonomous world brings to people? Like, what value will it create for all of us?
Right. I think it's just gonna be more fun.
Yeah. No. But it's true. I actually think like playfulness is super important here. Like society is inherently playful, and I think that's something like as we go towards like our algorithmic dopamine future right now, where like things are becoming more and more boring and like scary. I think that bringing some like autonomous chaos to the internet is going to be quite interesting. And I think the thing that's crazy with crypto is that because we have this much dollars at stakes, it automatically creates like crazy emergent properties. Like meth would not exist if like the TVL of Ethereum was like $1,000. Like nobody would care. And so I think that if we go towards playfulness and emergence and just interesting new affordances on the internet, like you shouldn't put your social life on the internet. You should like unlock things you didn't have before, right? People play EVE Online because they can control like galactic corporations, not because they want to like, I don't know, be a mailman. So I mean, there are games where you can be a mailman, to be fair. So, but yeah, new affordances, I think.
I'm personally excited about like just accelerating the amount of like talent that is building on the EVM. Like so many people that I know got started programming by like, you know, playing Minecraft and trying to build plugins or like trying to hack whatever game or build bots for whatever game they're building. And I feel like if all of that is being done on the EVM, like you're just gonna have so many like so much young talent that like they want to win this game so badly that they're gonna like become the best Solidity programmer in the world and like build some crazy indexing service and like run their own node and like, you know, spin up infrastructure that like companies like Alchemy already have, but like they're just gonna do it in their basement because like they want to be the most competitive player. I feel like that's gonna be super sick.
Don't underestimate the kids. You want to bring the kids to your technology, basically.
Yeah, maybe my answer to this is going to be super like frou-frou. Like I'm going to zoom way out. I'm going to ask here like, well, you know, what is the purpose of life? All right. And I say this kind of sardonically, but really what I want to get at here is like there's all sorts of games that we play in real life that we take very, very seriously. That like, you know, for example, like global capital markets are a game. You know, like going to a university to get a degree is like playing a game. And in all of these cases, like, you know, somehow I think that there's this bias towards like calling certain kinds of constructed games real and other kinds of constructed games like fake or something. And like one argument that people try to make is that like, oh, you know, like in the real category of things, like participating in like, you know, global capital markets or like, you know, the academic system. Well, you need to do that to like, you know, survive. It eventually boils down to like food or like, you know, owning property or like having a house over your head or having more like material possessions. But I mean, if you really look at it, like, okay, first of all, there's a lot of games that we play that are quite circular. You know, everybody's like probably had the experience of being in some like weird like social bubble where for some reason a certain kind of action that you go through the motions of is like encouraged or discouraged for reasons that aren't actually grounded. And the second thing is like, you know, even for the games where you're going to claim they have grounding in ultimately like survival or something, there's a lot of extra fluff around those things. Like you actually don't need that much to continue like existing as a human being. So like a lot of the interesting, like I think, you know, a lot of the like what it means to be a human and participate in society is basically to like be an agent in like increasingly complex games. And some of these games live in the physical world. Increasingly, we're finding like a lot of these games live in the digital world and actually are quite interesting, whether those are games like EVE Online or whether those are games like running B2B SaaS companies that, you know, like provide infrastructure, like create value for like other B2B SaaS companies. And I think that like, you know, this is kind of like, maybe this all sounds like kind of nihilistic, but like, you know, I think that there's a very optimistic viewpoint around what this digital future holds, because with these increasingly composable and interoperable like substrates for like all this sort of emergent complexity, we're going to be able to keep finding new and more interesting games to play with each other. And to me, that's what's exciting about autonomous worlds. And even though these things are just like tiny little seeds right now, who knows, like we might find ourselves taking seriously just as much as our like online social and financial interactions as we do our IRL ones.
I mean, like this crowd is like really great for that argument because everybody's here because you play one of the weirdest game ever. Like most of you are paid in like fake money or like fake money that got turned into like fake dollars, and then like it's pretty insane that an entire industry spun around like again Ethereum mainnet as like the most interesting MMO right now, and I think that like yeah, nobody better than you folks to get that, I think.
All right, thank you everybody for joining, and thanks to Gubsheep, Kevin, Alvarius, and Justin for having a great panel. And thanks to Ayush for being a great co-moderator as well. I think we're going to take a break now. Actually, I don't think we have time to take a break. I think we're jumping right into some really interesting lightning talks. So stay tuned.
We will take a, oh, sorry guys. We will take a mini break in the sense that we have to get our lightning talk folks up here and get some stuff on screen. But let's just have another round of applause for everybody on stage. Awesome, wide-ranging talk. I don't know if that's what you guys expected when you were coming to a Autonomous Worlds panel, but it certainly delivered. Thank you, guys. Can I grab everyone who's doing a lightning talk to come up to the stage, and then we'll kind of get you guys sorted, and probably about 3 or 4 minutes, everybody, and then we'll start with the next piece of programming. All right. I think we'll probably start taking off the chairs. Are each one of you guys, do each one of you guys have a computer, like, presentation tools or like okay, so does it I mean, I think that's a I have, this is the one I have. I have Fraser, Flynn, Leith, Omar, 0x Hank. So Fraser, you want to go up there and start jacking in, and then if you could just be ready for the next thing. Do we have access to like the speaker? To the what? It depends on how you set up like your, you probably would have to go into your settings, and instead of doing mirror, you would switch it to you can either hold or Ayush. Put that guy open, and then there should be a little. Do you mind giving that back to our guys? There you go. You can use this if you like. And then I'll pass this over. You'll hold, or do you want it mounted? Okay. So then let's just. Check, check. Hello. All right, everyone. If you can grab your seats, we're going to start with our lightning talks. All of these lightning talks are coming from folks who are participating in the Autonomous Worlds residency. Justin alluded to it before. It's basically a 3-month plus residency that 0x Park's Autonomous Worlds division is running in London right now. All these people basically represent either themselves if they're on a solo project or other awesome teams, either building stuff from scratch from the beginning of the residency or bringing in cool games they were already working on. There's a blog post on 0x Park. If you Google 0x Park Autonomous Worlds Residency, thank you, you can read more about it. I have the pleasure of being out there in London with them, and it's an awesome group of guys, so I'm really stoked for these talks. First up is Fraser with roll-ups as shared hallucinations. So round of applause, and we'll get going.
Hello. Hey, everyone. Hey, I'm Fraser. I'm one of the residents at the Autonomous Worlds Residency that 0x Park is hosting. And yeah, I'm really grateful to be working with such awesome people and to talk in front of you guys today. Roll-ups as shared hallucinations. Don't worry, it's like a clickbait title. I just used it to get your attention, but hopefully it'll make more sense as we go through it. So what is this talk? It's kind of a first principles look at roll-ups for gaming. Basically, the story was that I tried to build a game, and it was like very gas intensive, so I just kept optimizing it by adding more and more ZK and more validity proofs, and basically just ended up with a roll-up. And it's also not, this talk is also not a masterclass in game networking, so if any of these ideas kind of suck, just like let me know after. I guess one thing you might wonder is like why use rollups? The first thing, which everyone's probably pretty familiar with, is you get lower gas fees, but you maintain the security of Ethereum. In some way, you're like moving computation off chain and like perhaps batching it up in some way that's like cheaper. But the other thing, which I'm much more excited about, is new affordances. So I think the key thing is that the design space for rollups is really big, and as long as you're just like maintaining that L1 security, you can like do whatever you want basically and build new games. But anyway, yeah, like just for now, let's forget about rollups and just try and build games and see where we end up. So the first one I want to work on is just this basic on-chain game. Of course, on-chain games, like you guys have probably heard all this stuff, it's just you're using smart contracts to enforce the game rules. The games just live forever on the blockchain. It's really cool, emergent, whatever. And the one we're going to look at here is an on-chain auto battler. So basically, these two NFT characters are going to duke it out for like 1,000 rounds, just kind of repeatedly punching each other, and then whoever has the most health at the end wins. What might the contract look like for this? Basically, you just have this battle function, you take the health for each player, and then you loop through 1,000 times, and every time you detract the health of player 1 by the strength of player 2, vice versa. And then at the very end, we kind of set this winner variable, which is telling the rest of the blockchain, this is the winner, like this is the best NFT. And like, yeah, this is what the lifetime would look like. You just deploy the contract, and then you call this function, and then the game's over. Kind of boring. And like, there's obviously one fatal flaw with this contract, if you've done any blockchain programming, which is like, of course, maybe this for loop. It's like a total gas guzzler. Every one of those operations costs some gas, and then if you do it 1,000 times, it probably won't even fit within the gas limit, and it just will fail. So that's why we want to like try and get rid of that and build a game with like low gas fees. And so this was the optimization that I kind of ended up running into, which is basically, I mean, so the key thing to look at is only one part of this contract is actually like doing important stuff, and that's actually the part where you set the winner. Like that's what we actually care about when we're interoperating with the rest of the chain. This first part is just kind of like enforcing the game logic. So like ideally, we want to try and remove that. But if we do, like what do we replace it with? And if you work in ZK, you know the answer, it's going to be a zero knowledge proof. Maybe that's not actually that obvious, I don't know. What you do is you basically take your battle logic, you rewrite it as a circuit so that it's like you can make proofs about it with a snark. Just trust me, bro, this is the same logic as the contract. They're roughly equivalent, except from some stuff with circuits and like field elements that might give you different answers on different inputs, but pretty much. And I know what our smart contract looks like is basically, this code is like really huge and probably hard to read, but basically now what happens is anybody can come along and tell the contract who they think the winner is, and they provide a proof that that is actually the right winner. And as you see here, we just call verifier.verify, and we just, like, that's it. The contract just knows, according to that proof, who the winner is. And that obviously has a much lower gas cost than just like looping 1,000 times. And yeah, this is what it looks like. Deploy the contract, generate the proof, and then settle up the game by supplying the proof and the winner. And this is like probably not a very accurate graph, but basically, as the verification cost for these proofs is constant, you kind of like, you reach this point where it's actually worthwhile to bundle everything up into a proof and just verify it, rather than doing like the raw CPU compute on chain. This is probably not a very accurate graph, so like, yeah, also at me after. And that's the same diagram twice. But yeah, the problem with this game is that it's just like really boring still, right? It's like you just generate a proof and you just fight automatically. There's like no player inputs. So next step, let's build a multi-step game. Basically, I just mean a game where like players actually have some like effect on the gameplay. And you imagine like we could have player actions. So the contract gets deployed, and then players can take various actions. Think of that in like Dark Forest, right? And then at some point, the game will end, and then maybe we'll look at like which player has the most points, and they win. And like, what are the insights I think for approaching this in kind of like this, so like this ZK context, is that if you know like the rules of the game, the current state of the game, and you're given a player action, you should be able to look at the rules and figure out what the next state of the game is. But it's the player actions that are really difficult to get consensus on, right? Like if you imagine in a Web 2 game, people are just like throwing these packets around, saying which things they want to do in the game, and it's like not very clear when each player want to do certain things, like what exactly they want to do. So what we do with this is we try and use the blockchain as a clock. So players just like submit their actions on chain. Right now they submit them without any verification. We just let them post whatever they want on chain, pretty much just random bytes. But it's all time-stamped. So we kind of know what players want to do and when they want to do it. And then we maintain this like on-chain commitment to player actions. You don't really need to read that, but basically the idea is that the blockchain is committing and saying like, these are the canonical list of player actions. And then when a player wants to move, say this is like our smart contract, perhaps like, as I say, we'd usually have verification, so we're checking that like, you actually own this character before you can move it. But in this case, we're just gonna like remove that and then just add the player's action to this list of actions. And this slide is like a total mouthful, but basically what we're gonna do is once we have all these player actions, we're gonna validate them with a ZK proof at like the end of the game. I have a good graphic for this, I think, thanks to Stable Diffusion, or not, I don't. Okay, yeah, so you can imagine this guy up on the top left is like our ZK proof. He's like the judge of what's valid or not. And so it's gonna just like basically, at the end of the game, it's gonna loop through all the actions that we submitted on chain and just kind of compute the state of the game over time, like updating everything. And then it's gonna loop through all the actions, and then at the end, it's gonna say, okay, according to the game rules, this player has the most points and they win. And then they publish, this is also like really big to read, but basically they output this thing called a state root, which kind of, you can think about this as like, it gets rid of all the intermediate state of the game, because at the end of the game, we don't really care about individual player stats and stuff. We just care about like maybe the prizes. So one player has like 100 die, 20 die, et. And anybody can come along to the smart contract and say like, okay, here's what I think the final state is. And then the validity proof will say, yes, like, I approve. And yeah, and then that gets set. So it's kind of like anybody can like permissionlessly finalize this game, but it's all validated by the ZK proof. And then the reason that the state root is like a root, it's like a Merkle root, is so that at the end of the game, like users can come along and withdraw a prize or upgrade their character or whatever like that. But because it's just a single commitment on chain, it's all like very gas efficient. And yeah, this is what the game might look like. So you deploy the contract, players take various actions, the game gets frozen at a certain time, and then somebody comes along and settles up the game, and then everyone can like withdraw their tokens and, I don't know, like prove that they've won the game or something. And yeah, and the idea here is that everybody's just like simulating the game locally, but we use the blockchain as like a source of truth for actions. And I think this might start becoming clear, like this whole like hallucination clickbait title. Yeah, hallucinations. What do I mean by that? Basically, like, because we're using we're not like validating player actions during the game, that data just like doesn't mean anything on the blockchain. It doesn't actually like update the blockchain state immediately. But because we know the game rules, we like understand what that information means. Gigabrains. And so does the proof. The proof also encodes and enforces these rules for us. So like someone comes along and tries to submit a different action, the code will kind of interpret that action within the rules of the game, and then say like yes or no, like is that valid? So like the player on the right is like trying to do something that isn't a valid move within the game, and then the proof is like retroactively saying no, you can't do that. You cannot blow up the whole world. But you could write a proof that like makes that a valid action if you want to. Yeah, so as I say, the validity proof is like retroactively enforcing the rules, enforcing the history of our game, and basically making our shared hallucination real. And I think like thinking about games in this way is super efficient because we just all just like believe the same rules and we all just play the game without without having to check each other, and then the proof will just like sort things out after. And actually, like when you think about it, this system is actually technically a ZK rollup. It's not like the ZK rollup that you're used to. It's kind of like a fully decentralized rollup without a sequencer. No offense if like the optimism people are still here. I think their system's probably better. Yeah, players are just committing actions directly on chain. Yeah, do I have like much time left? Okay, I'll go through this bit very quickly. So basically there's this problem of like world forwarding in games. So basically like you want to do things like you want to have like things move over time like water. Maybe this would be like OPCraft 2.0. Like crops growing over time, realistic physics, AI, which is actually the same image as the moving castles talk. Yeah, but the problem is it turns out it's actually super hard to do this in the EVM. You have like different approaches like eager and lazy world forwarding, but they're all basically working around the same problem, which is that the EVM is like fundamentally an interrupt-based system. Things only happen on the blockchain when players submit actions to update the state. But if you think about the real world, or you think about traditional games, they all like have this idea of a tick, and the EVM just does not tick. And it turns out that the gamers want ticks. It's actually really helpful for games if they just like progress naturally and you have NPCs and AI that just evolve over the course of the game. Basically, the EVM almost did tick. There's this idea of an alarm opcode, but it turns out there's like fundamental problems with this that make it really difficult to actually implement this on a blockchain. And like if we did have that, it'd be really cool. But the problem is that like you only have so much processing on a blockchain, so it's like who gets to tick, basically. And the only thing you can do is just build a chain and like enshrine the most important updates you want to happen every block, like directly into the protocol. And actually, 0x Hank and Lermchair did a really cool experiment with this, where they modified Geth to like take over their little game of life game, like every block, I think. And yeah, like somebody needs to do this. Like there's so much fun you can have with like building just rollups that aren't EVM compatible and do their own thing. And with our rollup, it'd be pretty simple. You would basically just, rather than like looping over every event, what the validity proof would instead do is like loop over every block. And then if there's certain actions in that block, it will apply them, but it will also do different things like growing crops, updating NPCs, projectiles. And yeah, so basically I built like a first prototype of this kind of rollup system. It actually has nothing to do with games, it just does payments, but I've never built a rollup before, so it was kind of nice to start simple. That's the link for it there. And there's also a client that will sync you with the rollup too. And yeah, like next steps for me is like I really want to keep thinking about this, probably make a game that actually does this, and kind of like build these ideas out and formalize them into something that's like more of a protocol, more of a standard, and do this pretentious thing of like making it easy for you guys to spin up ZK rollups that are evanescent and only last for a certain amount of time when you want to simulate really complicated high compute games that are like maybe more like Web 2 games, you could say, to employ that. And yeah, let's all hallucinate digital worlds together.
That's the problem. Awesome. One more round of applause for Fraser. When all of these folks signed up to get some accommodations and work on games in London, we didn't tell them they had to also present at DevCon. So thanks for putting all this stuff together. And we'll just let Flynn get his AV set up and let me know when you're ready, and we'll kick it off.
Should just automatically work. I'll try duplicating. There we go. Okay, it's connected. Let me try extend. I wonder if that'll mess it up. Ah, cool. Yeah, look, there's my background. Alrighty. Okay, I'll try doing this. And then we can do, hey. Nice. Alrighty. Good to go.
Well, it's all up there, but round of applause for Flynn for Autonomous World Discovery.
Howdy. All right, so this is a talk called Autonomous World Discovery, and it's by me. So if I can go through. All right, so a little bit about me. I'm Flynn, I'm 23, and I'm from Australia, over there. I only properly got into the kind of blockchain space about halfway through last year, so that means I'm still a cryptographic baby. Since the start of the year, I was working at a cryptocurrency exchange in Australia called CoinJar, no longer. And since about mid-September, I've been participating in the Autonomous Worlds residency in London. And so far, it's been absolutely incredible. And I want to say a huge thank you to the Lattice guys and the 0x Park guys. Without you guys, I wouldn't be here today. At the residency so far, I've been working on a prototype for a new game that does some cool things with ZK mechanics and information asymmetry, but it's not ready to show off yet, so I won't be talking about that today. So what will I be talking about? Well, Autonomous World Discovery. So for a while, I've been pretty interested in the prospects of a discoverable world within a blockchain context. So what do I mean by a discoverable world? Yeah, so what do I mean? Well, players do not initially know the entire state of the world. They have to perform actions to incrementally gain knowledge of that world over time. To know what's out there, you have to go out and see it. In the traditional server authoritative model, or the God server model, I'll be calling it, you simply store the whole map on the server, as well as the player's positions, and when a player moves to a new section of the map, you simply send them the data for it. The player cannot see the entire map. They can only see the pieces that the server sends them as they move through the world. So what do I want? I want to achieve this property of discoverability without the need for a persistent centralized information holder. I think the idea of going out and exploring a virtual world where not only you don't know what's out there, but nobody knows what's out there is pretty compelling. I think that's a true digital frontier. So, Dark Forest. Dark Forest already does this. In order to see the contents of a specific chunk of the map, you have to mine it using hash power. Pretty cool. I have much respect for the Dark Forest team and what they've done, but there are two aspects that I contend with. One, map discovery is random access, meaning that you can choose which parts of the map that you want to mine entirely independently of the positions of the planets that you actually control. And two, the rate of discovery is based on something entirely external to the game world, your hash power. So what I want is a system that is locality dependent. You can only discover the world in your immediate surroundings. And the rate at which you can discover the world, let's say it's the rate is bounded by or determined by the rules of the game world entirely and not influenced by anything external. So how do we go about achieving that? Well, let's try attempt number one. Let's say we have a tile-based world where the contents of each tile is procedurally generated using Perlin noise, with multiple levels of noise for better generation variety. However, yeah, so we got that. However, instead of the seed being fed to the Perlin noise algorithm for a specific tile being deterministic, the seed is taken from a random oracle and is only determined when a player
reaches that tile for the very first time. And so it's like players are venturing out into a constantly forth into a constantly shifting world that only solidifies when they get there. So this approach preserves the locality of discovery, as the players can only discover tiles that they are physically moving onto. And it also ensures that the rate of discovery is not dependent on anything external to the game world, as the rate at which you can move through the world is determined by the rules of the world. A natural extension to this is that rather than simply discovering the tile that you're moving onto, you would discover all tiles in a kind of radius around your current position. And that way you get kind of like a circle of vision and you trace out a path over time, which is important because you want to know if the next tile that you're about to move onto is going to be lava or land. And you can't do that with just a single tile at a time. This random seed for each tile would then be saved into a mapping from positions to seeds. You can see that there in the code. Such that subsequent players reaching a tile would find that same seed, which ensures that, that same seed rather than getting a new seed from the oracle. This ensures that world permanence is preserved, although I do think there is something interesting in intentionally breaking world permanence, kind of shifting sands, crumbling castles. Oops, too far. So, preserving world permanence in this system also means that world discovery is public because the seeds are published on-chain. A discovery for one player is a discovery for all players. All right, so this is pretty cool, but what I really want is private discovery. I want to be able to go on an adventure into uncharted territory, discover a dungeon that no one else has seen before, now only I know about its existence. Then I could go and tell my friends about it, and we could go loot it together, or I could sell this information to someone else, or I could publish it for the world to see. Regardless, at the point of discovery, that information has value, and I think that's cool. Is this even possible, though? Is it possible to privately discover information about a world that's publicly hosted on a blockchain? Is that published? Is that possible? Enter witness encryption. So I first heard about witness encryption from a video that Justin Drake did on combating MEV, specifically in relation to encrypted mempools. So how does witness encryption even work? Well, I'll quote JD directly. With witness encryption, you can encrypt a message such that in order to decrypt the message, you need to provide a witness proving that some statement is true. And then this could, and this could be any statement. In other words, you can decrypt the message if you give it some snark, basically a short proof that some statement is valid. Underneath that, right there is that's the title of the YouTube video. I highly recommend checking it out, it's great. So this is literal witchcraft and sounds too good to be true. My general understanding is that currently practical implementations of general witness encryption are far from being feasible, but my hope is that over time, the same thing that happened to ZK technology will happen to witness encryption. And over the next couple of years, it'll become dramatically more feasible. All right, so how does this relate to world discovery? Well, let's say that we have a world that consists of a set of interconnected rooms, a dungeon of sorts. A world architect privately creates the set of rooms and their contents, publishes the data describing the set of rooms and how they're connected, and also for each room publishes a locked tome. They then cease to exist. That was their final contribution to humanity. So what is this locked tome? Well, it's the data that describes the contents of the associated room, requiring a proof to decrypt its contents. So it's witness encrypted, with each tome requiring a different proof. This proof verifies that 1, there exists a valid path that actually leads to the room, and 2, and this is where it gets a bit wacky, that the player actually committed to taking that path on-chain. Otherwise, they'd be able to generate a proof going to every single room, figure out which rooms hold the best contents, and then only commit to taking that particular path between those particular rooms on-chain. So that's where you need the actual proof of on-chain commitment as well. In this example, in order to find out what's inside room C, you would have to show that there is an actual valid path from A to B to C, and that you have committed to taking that path on-chain. So how would you achieve POOC, or proof of on-chain commitment? Well, you would start with proof of consensus, where you verify the attestations of the current validator set for a particular block hash, which is something that I'm pretty sure Succinct Labs is working on currently. And then using that block hash would use proof of storage slot, which is a term that I originally heard from Fraser, which is essentially just a Merkle proof that the commitment to the path exists on chain based on that block hash. I'd like to think that there's some simpler construction that you could build on top of the consensus logic that's easier to verify, but still gives you the same guarantees as like full proof of consensus. But who knows? So what are some drawbacks to this system? Well, yeah, cool. Sorry about that. Well, it requires the initial world architect, a divine creator, to bring the world into existence. It's better than the God server model because they're no longer required after that initial publish, and so the world can continue without them. But if they don't cease to exist, then they can exert undue influence based on the fact that they know the contents of all the rooms. Kind of like the toxic waste that's created during a trusted setup, but just less deadly in this case. Also, after the initial creation of the world, it essentially remains static and finite. And so there is there's less long-term dynamism in the discovery, as well as players will eventually, because players will eventually discover the whole thing. You could have the world architect continually add new pieces to the world, but then you're essentially back to the God server model because they have to continually exist. So, can we do better? Synthesis. We take the incremental tile discovery system from the first attempt, and we inject witness encryption. Well, what does that look like? You still fetch the tile generation seed from the random oracle when discovering a new tile, but now, instead of publishing that seed directly, you publish a witness encryption of the seed, requiring a proof of valid path and proof of on-chain commitment in order for it to be decrypted. Boom, you've both achieved private discovery and preserved world permanence without the need for a persistent centralized information holder or predefinition of the world. However, although world discovery is private, your position would still be public since you have to update the position to witness encrypted tile seed mapping that you see at the top there. Oh, also, did I forget to mention, whoops, we went too far? Yeah. I forgot to mention that when publishing the witness encrypted tile seed, you would also have to publish a ZK proof showing that you actually did the witness encryption correctly. Yeah, so this is pretty clearly whacked out beyond belief and is very far from being practical or even remotely practical, but maybe one day it will be. That would be pretty cool. All right, so we're already at this level of ludicrousness. Can we go further? Of course we can. A homomorphically encrypted world generation system running on chain, where you feed it your encrypted position and it gives you back the encrypted world data for that position, as well as updating its internal state. And when I say this, when I say on-chain, what I really mean is probably across a series of recursive ZK proofs in order to minimize on-chain compute cost. But maybe we'll eventually get to that point where all on-chain computation is done that way, so the distinction will actually break down. While you're at it, oh yeah, I should do this. Yeah, cool. That's that part. While you're at it, you may as well put the entirety of the world logic into this homomorphic system, meaning that the rules of how the players interact with the world and each other, then yeah, so that's the rules that you put into there. And then, funnily enough, that means that we're effectively back at the God server model, but now it's running entirely on-chain, autonomously, and we can have confidence in its robustness. So that's that part. With this system, we can now have private discovery of the world while maintaining privacy of your position. Theoretically, you should also be able to do something that seems natively difficult to achieve when positions are kept private. Player discovery, how do two players know that they've run into each other when their positions are private, when they don't know each other's positions, and private player discovery, the ability for player A to discover player B without player B discovering player A. And while you're at it, homomorphically encrypt my consciousness and put me on chain. That way I can live forever. That's the end of the talk. Thank you very much.
Hello, check, awesome. If any of you tell, we're running a little bit behind, so I just want to give a slight update. We're going to stick, with this schedule. They're still going through the lightning talks, and we'll end with the mud chat. But the lightning talks will probably run until 3, and then the MUD presentation will run from 3 to 3:30, just because we're a little bit behind schedule. So I just wanted to give you guys that update, and we'll let Leith get set up here and start our next lightning talk.
What am I missing on here?
Should work. Come on, you want to unplug?
We got it. Hello. Is this mic turned on yet?
Check, check.
Yeah, sure, please. Check, check. Okay, this works. Hey there, I am Lethy from Asphodel. We're one of the teams working at the Autonomous Worlds Residency. We are working on, I guess it would be best described as an autonomous on-chain MMO, but I'm not going to be talking about that today. What I want to talk about and touch on here is, I guess what I think of as the most key emergent aspect of these systems, which is the economies. Now, when you create an autonomous world, you create, in almost always, there will be a system of resource production and consumption. So to use OPCraft as an example, you can mine blocks, you can place blocks, you can craft blocks, you can do a few other things like staking diamonds in order to claim chunks in the world. And that's a very specific set of predefined affordances. So that autonomous economy is the emergent system that evolves from that set of affordances that are placed in the game. So what this means is when we design an autonomous world, we're designing the fundamentals of an economy, of a human social system that can potentially go far beyond the game we build. And as builders, we define those fundamentals. We define how each of those points works. So we can define the rules by which players are bound. How do they move? How do they harvest resources? We can define the degree to which the world rewards cooperation versus antagonism. So do you need to work together? Can you mug people? Is there an in-game $5 wrench attack where you can take someone else's resources? And how do those resources work? Where are they available? What's their supply? How are they collected? And when you put all these things together, you get the seeds of a more complex social system. So we define the rules, but not the game. Users can build on top of these things. They can play on top of these things. And the really unique aspect about autonomous worlds that I think makes these emergent social aspects far more powerful than a traditional computer game is that players and community can build on top of those rules. So they can literally add smart contracts. So again, using OPCraft as an example, there's nothing stopping devs building DeFi on top of Minecraft in this system. There's nothing stopping them creating NFT marketplaces that allow people to resell blocks. There's nothing stopping them deploying new smart contracts that expand the game functionality, that might add new creatures, new things you can do. There's nothing stopping them creating in-game DAOs and much more. I'm sure there'll be visualization services, explorers, knowledge services. It's pretty much impossible to predict what people will build. And when we put all this together, we get a complex economic system, predefined parameters, rules of interaction, and human beings as independent agents within it. And we do have a fairly big one of those in this world. It's called capitalism. And this means when we're designing autonomous worlds, we have a pretty much unprecedented opportunity to design economies. So fine-tune rules of human interaction, to fine-tune the primitives, and then see what evolves from them. And the potential for that evolution goes beyond anything we've seen in gaming or virtual worlds before. Not only do players socialize and play in the ways that they wish, they can expand the technology, they could potentially build extra games on top of the original game that might use its resources or interact with it in one way or another. And so we find ourselves in a situation where rather uniquely, we can define a human economy and the fundamentals of it in a way that hasn't really been possible in most systems. Some DeFi protocols may work in this manner, but games, worlds, it hasn't really been possible in this manner before. EVE Online is a pretty good example of probably the closest thing in a traditional video game, but it's not decentralized, it's not autonomous, and it's still controlled by certain centralized aspects, CCP specifically. And so now we find ourselves, we can build real-world economic simulations. We can forget about everything and we can build crazy, creative stuff that's pretty much unprecedented. And over the next few years, I think we're going to see potentially tens or even hundreds of different models evolving on top of these autonomous worlds. So what kind of things? What might these look like? What might we do? So we can go simulationist. We can try within autonomous worlds to mimic real-world economic mechanisms. We can say the resources are scarce, trade is constrained in certain ways, and we can attempt to really replicate the real world. Now, some genres, this works naturally. RPGs, management games, strategy games. In all of these examples, simulationist economies can make sense. But they also have potential uses beyond fun. So consider in 10 years' time when the autonomous world space is more mature, economists could use these sort of mechanisms to essentially prototype and research new macroeconomic models. This is something that's currently pretty much impossible. You can't A/B test tax rates. But with sufficiently advanced autonomous worlds, it starts to become impossible to do those. It starts to become possible to do those kind of things. It starts to become possible to do social experiments, academic experiments, and in general to simulate real-life economies in a particularly detailed way. And we can also go in the exact opposite direction. So we can go experimental. We can do things, if anyone's heard of Reddit/r/place, which is a kind of collaborative process of placing pixels on a screen together. This, in a way, is almost like a kind of proto-autonomous world. Independent users interact with the world. They build things together. They have a very specific affordance, which is they can place 1 pixel every 15 minutes. And so this world evolves together as a collaborative artistic piece. So /r/place on Reddit, they do this, I think, every year or so now, and it becomes a huge thing. People compete. Thousands and thousands of people come and place pixels together. There's no reason you couldn't do this kind of thing on chain using autonomous world check. You could do it in 3D too. You could do a Minecraft version where only a finite number of blocks are available, everyone builds together, and they create something new. And again, that's not really what we think of as traditional economy, but it is defined by economic rules. And we can combine this with the simulationism. We can do simulationism with a few elements off. Again, that can be an economic experiment, or it can be for entertainment, it can be for art. And of course, since this is crypto, I feel obliged to add, we can do competitive autonomous economies. So we can create antagonistic PvP systems where in-game resources have established liquidity with external markets. And what I mean here really is creating something that's a kind of viciously competitive PvP space. So in some way you bring in funds from on-chain and you essentially bet them on playing the game. You put money in so you can steal other people's money. They put money in so they can steal your money. This becomes a kind of hyper-aggressive competitive game. Now the interesting thing about this, the model that most closely resembles this type of autonomous world is actually a type of DeFi product called perpetual futures. So I'm not going to try and explain this right now. Perps are infamously difficult to grasp. But the point is, with perps, there's no underlying asset. People trade based on market prices, entirely based on collateral on each side. So if the price goes up, some people pay some other people. If the price goes down, some people pay some other people. It's a game. It's a collateralized game. It's not actually a financial product at all. And many people don't realize this. But perps, which are essentially a completely PvP economic simulation, they're responsible for some disgusting proportion of exchange volume. People love them. Like massive, massive amounts of money in crypto trading essentially go through what is a collateralized paper trading game. It is a video game. And so we can do the same kind of thing here. And we can make it more fun. We can make it competitive. We can make it aggressively PvP. We can add these kind of elements to a shooter or an RPG or an MMO. And again, you might combine this with the simulationist aspects. So you get a simulationist game that in its way is also more viciously competitive. This is, I guess, a trap for Homo economicus. It's kind of like the perfect simulation for someone's more competitive. We can also, as mentioned, go experimental, go more Homo ludens, and do things that are more creative, fun, and exciting. And of course, we can merge the two of them. There are hundreds of permutations of how you might use these different models together to create autonomous world economies. So this is pretty much a completely untouched field. No one has really worked with this before. Only a handful of MMOs, EVE Online, and a few others have touched on this. But they're not autonomous, they're not decentralized, and they're not composable. So we take all the economic firepower of those games and we vastly magnify it, and expect to see interesting developments here over the next few years. I think, just to close off, fundamentally, pretty much all autonomous worlds are going to evolve economies, because by definition, an economy is just a social system of human interaction. So really the point of my talk here is that every autonomous world can also be seen as an autonomous economy to some degree. I suppose you could really try to stamp out the economic aspects if you wanted, but in almost every case, these kind of economic developments are going to be fundamental to every autonomous world. And I'm sure plenty of you in the audience, I hope you've got some cogs whirring in your brains now about what could be done with this, because the potential, in my opinion, is huge. And yeah, I'll close off there.
Awesome. Thank you, Lethe. Up next, we have Omar, but I'm going to let him get jacked in, and then I'll do a proper introduction. And once again, if anybody's trickled in since the last time I chatted up here. We're just running a little bit behind schedule, so we've got 2 more lightning talks, and then we're going to get to the mud presentation. So the lightning talks will probably take up the next about 15-20 minutes, and then around 3 o'clock we'll have the presentation on mud. We do lose our kind of AV support and everything like that at 3:30, but it's not like a hard close where people get kicked out of the room. So if you've been inspired by any of these talks, feel free to hang out, chat amongst each other, talk to folks from the team if they don't have to jet off. And that's enough time killed, I think. Can I get a round of applause for Omar? He's going to give us a presentation on lessons learned building a fully on-chain auto battler.
Yes, I am good. Thank you. It's a little high. Okay, awesome. Yes, so I will jump right into things. Quick intro for who I am and my co-founder who actually just flew out this morning. My name is Omar. I don't have a super cool like 0x name. I do have a sweet tooth, so that's why it's Marzipan. Some of you might have read my blog post about Dark Forest, the genesis of sort of the on-chain space. It's on Mirror. Please buy it. It's my only source of revenue right now. Me and my co-founder basically spent the past 3 months building a game called Magic Galacticats. I'll talk a little bit about the game. You can actually play a version of it today. It's launched on Optimism Girly. You can't play it on mobile though. And it's essentially inspired by other on-chain, or rather not on-chain, other auto battlers. So games like Teamfight Tactics, Hearthstone Battlegrounds, except it is running fully on-chain. So one of the other cool things is that, since we're just a 2-person team, we did things like we used DALL-E 2 to generate all the card art. That's why it's about cats in space. DALL-E 2 is very good at that sort of abstract thing. So use the tools that exist. Don't fight them. Yeah, inspired by games like Battlegrounds on the left, or if you've ever played the indie game Inscription, excellent game, very simple card game. Highly recommend it. Super quick, just overview of like how, or rather what we learned. Basically, like building a game is hard. Prototyping is really important. And specifically, if you're going to build on-chain, you really have to understand the constraints of, well, like the on-chain backend as a design pattern. So we'll be diving a little bit into that. So basically, a rough overview of how we built our game. So it took place over the course of the summer, about 3-ish months. We had a playable version after about a month. We basically forked the Dark Forest codebase. We tossed out almost all of their contracts and almost all of the game client, but we kept a lot of their tooling. So for example, we built on top of the Diamond standard, and so it was really useful to sort of just have an example of what that looked like. Go ahead and, yeah, just a super quick overview of the code, just to like ground what this actually looks like from a developer experience perspective. Most of the time that we spent was spent on the front end, not the Solidity backend. Again, we used the Dark Forest codebase, so we had some really nice tooling made by people like Blaine Bublitz to make building on top of the Diamond standard super easy. Hard Hat was amazing. Just coming from the Web 2 world, which is sort of like my previous job, like the development experience of Hard Hat kind of makes the like Ethereum ecosystem just feel like you're building on a serverless backend, which is, yeah, nice. Super quick overview of the actual game design if you're not familiar with games like Battlegrounds. Basically, cards can be played into slots. Players take turns consecutively, and once all players have ended their turn, the battle takes place, and then it's the next turn. So players, for example, don't select which card attacks which card, like in vanilla Hearthstone. That is sort of just dictated by the rules of the auto battle engine. Cool. Okay, so what was hard to actually build? Again, you might have gotten a hint of this based on the lines of code or how much time we spent on the front end, but the front end is by far the hardest part, which actually doesn't really have anything to do with the on-chain aspect. Just building multiplayer games in general is hard. Most game devs will probably echo this if you talk to them and they've built like any sort of multiplayer game. Distributed systems are hard. Games have the additional constraint of trying to bundle client state and backend state. So if you take a really naive approach like we did, where we just pull the backend, you start running into issues where a player will try to queue up actions, and then the backend pull will override it. So it's not as simple as, just pull the backend, bro. It's actually a little bit more nuanced than that.
Okay, and so building this stuff was hard, but there's a large body of just multiplayer game dev blogs that you can pull from. The actual hardest parts were just designing a game, which isn't that surprising because that's also the hardest part of building a game in general. So the simplest thing that I would just echo throughout this talk is just try to design the simplest gameplay loop as possible. So we took a lot of inspiration from the games that I mentioned, but we also just basically ripped off a lot of their gameplay patterns, and that was a really bad idea because most of the players that we talked to, even if they liked games in that genre, they hadn't played every single game in that genre, and so they didn't know what things like sacrifice meant because they hadn't all played Magic the Gathering or Inscription, for example. So we ended up spending a lot of time removing elements of the game from our first playtest rather than adding features. And then, of course, blockchains come with latency limitations, and I'll talk a little bit about those, but another big thing was just make it super simple for players to actually interact with the game. So since the game is on-chain, every single action is a transaction. We ended up making all actions batched client-side, introduced multiplayer bugs, but players were fine with the bugs if it meant they didn't have to click approve on MetaMask every single time. So this is just an interlude, maybe like hammering in that point of really focusing in on a simple gameplay loop. There's this game that I love called Dicey Dungeons. It was released in 2019, but it actually emerged from just like a 7-day game jam. So on the left-hand side, that's the game jam image, and on the right-hand side, that's like the final game image. So the core of the game was prototyped in the span of a week, and then of course it was fleshed out over the next year. But the guy who did this, Terry Kavanaugh, he's like an indie game developer. He has a great game dev blog. I recommend it. Cool. So understanding on-chain constraints. Basically, when we launched our first game, we didn't know what chain to launch it on. It was built on the EVM, but there's a lot of EVM chains. So we actually ended up launching on 5 chains. And we had 2 design goals. One, we didn't want it to be more than 5 cents a day to play. That was basically just, it wasn't pulled out of thin air. That was actually benchmarked from the state of normal multiplayer games. If you look at a game like Teamfight Tactics on mobile, they only make about 40 cents per average user per day. So you can't spend more than that because even if you're one of the world's most successful games, you just can't expect players to pay more than that. So we ended up benchmarking on a bunch of chains. The TLDR is there's no Goldilocks chain. So we ended up launching on a testnet, and that just means that playing the game is free. We also have a drip so that you don't have to go through like testnet weird like faucet stuff. But it also has like reasonable latency for at least like an auto battler, which is mostly turn-based. And then the last thing that was hard to design is multiplayer. Even though you do get multiplayer for free on-chain, it turns out that matchmaking and things like that are hard. I think actually the DFDAO team echoed that in one of their talks in the hackerspace earlier in the conference. So we ended up building a PvE mode because it was just way easier for players to play test at their own pace, and also for us. Cool. So yeah, just super simple takeaways. Start as simple as you can. Play test as early as you can. Definitely use a principled design like architecture for building your game. That'll just make the game client really easy to build. We basically just had a spaghetti game client. That's why there's still multiplayer bugs. So shout out to things like Mud that are standardizing that approach, and they have like super nice like phaser plugins. Yeah, definitely like put a little bit of thought into picking your chain, but honestly, like you can just ship it. Like the benchmarking was basically done over the span of an hour. Like it's not hard once you have the game built. That's the beauty of like the EVM being interoperable. You just write like a hard hat script that deploys to a chain ID. And then lastly, yeah, definitely consider on-chain limitations. Like test it in hard hat, but at the end of the day, the simplest thing that you can do is just minimize on-chain actions. Even if the game is fully on-chain, that doesn't mean that every single thing has to be an independent transaction. And that's it.
Awesome. Thank you so much, Omar. Last one. Last lightning talk. The crowd will decide that.
All right, one moment, guys. Where's music? All right.
Today I'm going to be talking about user-generated, or no, I changed the name. It's called Dynamic Canon Castles Guys Talk. So it just shows that that's what happens when I steal your ideas, you know? Flash forward to now, and wait, it'll be better if you see the slide because it's funny. We live in a world of, essentially this is the Web 2 world. It's a beautiful Web 2 world where everything is closed source. You can't really have access to building anything. Everything is designed for consumers, people who just want to sit back, eat their popcorn, and consume information. And this is okay. People get by on it, but I'm more interested in pushing forward into what we can do when we give people power. A new foe appeared in 2007 called the blockchain. And I think that the blockchain could enable one of many interesting properties of games that I call dynamic canon, and I describe it as a fluid, ever-changing, universal rule set in a game decided by the players of that game, which is enforced computationally. So before I continue, I just want to make it clear that content is not the same as canon necessarily. I view content as the things that appear within a game. So user-generated content is me creating LOL, or Valorum in this case, creating LOL in OPCraft. But creating new canon in a game is adding mental health into Minecraft. And so if you don't have any friends, you start to get really sad, and it just creates some new emergent properties. I think that the blockchain is the best medium for this dynamic canon to occur. And let's look at why. So I think that there's two blockers at the moment to creating dynamic canon. The first one is universality, which is the reach that our rule chains will create. So if I create a new rule, how many people and how fast will that spread throughout the entire community? And the other one is access. So can I go in and make these changes on the ground level to the rule set? Video games are really good for universality. A game developer can enact a new rule, patch it into the game, require everyone to download that patch before they continue, and there you go. However, obviously in MMO, people don't really have access to it, right? I can't go into the server and make some changes to the rules and do something cool myself because it's all hidden. On the other side, we have analog games like board games and video games. Or not video games, board games and sports and other real world games where it's really easy for me to just tweak a Dungeons and Dragons rule, but it's impossible for me, or it's really hard for me to share that with the entire game community really quickly and cheaply. I guess the internet is helping with that, but it's still a drawback. And in the middle, the blockchain, is that going to help us? I think it might. And this is because on-chain games afford both universality and access. When I make an update to a blockchain game, that update immediately and instantly becomes accessible for everybody who has access to it. A good example of this was in the last Dark Forest round, an unnamed developer left a huge bug in the code, and it created a massive point imbalance. Fortunately, the dev team could pretty easily go in, redeploy and upgrade, and fix that tweak. Also, blockchains allow for access. Since the game exists on a public substrate, the public blockchain, and anybody can write a smart contract to exist alongside that rule set, now anybody can have access to making and creating new rules. In on-chain games, another thing that really excites me is that consumers become player builders. So because the backend smart contracts are exposed, we allow for radical client customization since we've untethered that client to the backend. We've allowed for unstoppable botting or transaction automation. and we've allowed for alternative modes of play. So two people can interact with the exact same world in different ways. And that's what we call conviviality. For these reasons, on-chain gamers are more and more starting to look like on-chain builders, which is not really something you see in Web 2 games. So now let's dive into how I could make a new rule in a video game and make that rule canonical for everybody in the entire ecosystem. It kind of works via natural selection. Let's say I'm playing OP Craft, which is an on-chain game, and I hate the fact that you have to, I don't know, you can only craft 4 different things at the moment. And I really want to add some cool new crafting recipes to make the game better. So I can easily create it and deploy it to something like the MUD ecosystem, which you'll find out why very shortly. Anybody can play the game with those new rules. And if everyone loves it, then we can agree by consensus to incorporate it into the official canonical rule set. But if everyone hates it, then no one will use it, and it will naturally get filtered out of the universe. So over time, we get closer and closer to this new rule set that becomes enshrined by the players of the game themselves, which is an interesting property that has in the past been very difficult due to these issues of universality and access. So now we could move to a place where we are playing games that are autonomous. There's no single person who can put their name to making that game. There's no single owner, and there's no single designer. However, we also need to keep design in mind as we do this, because just building on top of a blockchain isn't enough. First of all, builders have to embrace permissionlessness. It's still possible to create walled garden games by using things like non-upgradability and restricting access. And so try to keep code simple and ungated and easy to build on top of to allow these emergent factors to take place. Make rule changes accessible. Scratch is the classic example of making code accessible to people. The Moving Castles guys touched on a couple of other games that do this really well, or you could use this thing called MUD, which you'll find about shortly. Make new rules discoverable. This is also a difficult challenge, but one that's pretty necessary. You have to figure out a way to let people experiment with new rules that people have created and share their findings so that everyone can narrow down to something that's really compelling and really fun. And finally, you have to let people disagree and fight. If people don't like a new rule, half the people don't like a new rule, half the people like a rule, someone's got to win, something's got to happen. It's just like the EVM, right? People have to be able to resolve these conflicts. The consensus has to be reached, and if it doesn't, you got to allow people to fork off and make their own games. Or else it's not really a truly autonomous world/game. And so me and my friends, Tony and David, part of DF DAO, we're looking to explore this in our next project. We're trying to create a substrate that allows players to create their own games and their own rules as player builders. And we're calling it, for now, Project UG, but that name is only temporary. Thank you.
Check, check, hello. All right, one more round of applause for everyone who did a lightning talk.
It doesn't matter.
All right. There we go. Okay, last but not least, and thank you guys for hanging out and staying later than we had previously anticipated. And on that note, I'm going to get off the stage really quickly. So if we get a round of applause for Alvarius, who's going to do Mud, an engine for on-chain games.
Cool. All right. My talk is split into two parts. The first part is going to be Mud in theory, and then in the second part, I'm going to go over a little case study of something we've built with Mud, which is OPCraft, and show you how we build it, basically. So to get started, what is Mud? Mud is an engine for autonomous worlds, or an engine for on-chain games that we've been developing at Lattice. And as I mentioned earlier during the panel, we started out building a specific game and then ran into all these very general problems that didn't have anything to do with the game design or the actual game that we wanted to implement, but rather were just caused by the fact that there was no engine that we could build upon. And so at some point, we decided to build this key missing piece of architecture ourselves, and that became Mud. And the goal with Mud is to basically solve all the hard problems of building on-chain games. So what are the hard problems of building on-chain games? They basically fall into three different categories. The first one is how to keep your contract and client state in sync without having to manually call the RPC node all the time, pulling content and stuff like that. Then the second one is how to architecture your game in a way that makes adding content very easy without having to refactor the entire game and the entire networking stack. And then the last part is, if you care about impact of your game beyond just your individual game, then how to make your game interoperable with other things that are built on chain. And before I go into explaining how Mud solves all of these problems, let me quickly go over how people have approached these challenges before. Normally, or the most common approach is per entity type on the contract, you create one type of struct that then stores the data for that type of entity. And then, of course, on the client, you have to duplicate that struct in an interface or something so that you can represent the state on the client as well. And then you implement custom getter functions for each of your custom structs to load the state initially, and then you implement your game logic, modifying these custom structs, and every time you modify one of these custom structs, you have to emit a custom event, and then that custom event has to be handled on the client to update the state on the client. And that already sounds pretty annoying, obviously, but it gets even more annoying when you want to add new content, because then you have to add new structs and you have to modify your entire network stack to incorporate this new struct, the events, the getter functions, the handling of the events, etc. And then on the interoperability side, basically all we have are existing standards like ERC20, 721, etc., that were not made for games and that are very limited in what they can express. So this is why we built Mud, to solve all of these general problems such that you as game developers can take care of making a game that's actually fun, which is also hard. All right, so this is for the why we built Mud. Now onto how Mud solves all of these problems. Mud is built around a pattern called entity component systems, which is a very popular pattern in traditional game design or game development. And if you're not familiar with it, I'm going to give you a super quick crash course in ECS. In ECS, we have entities, and entities are basically just a numeric ID. In our case, it's a UN256. And then you have components that are the data store for these entities. So you can have different types of components, and they basically are a fancy mapping from the entity ID to the component value in this component. And they don't contain any logic. The logic is introduced in the systems. Systems are logic that edits or that modifies component values, but it doesn't care about type of entity, because there is no type of entity in ECS, but rather an entity is just the collection of different components. So our move system, for example, doesn't care about whether it moves a donkey or a dog. All it cares about is that the entity that it's currently moving has the position component attached to it. And if you think about that, it's kind of like Ethereum already works in a way today, where you can think of entities or like addresses as entities, and then token contracts as kind of like a combination of component and system attached to them. And if you wanted to model that in pure ECS, you would just create a balance component that stores the data for that address, and then a transfer system that modifies that component value. All right, and now if we have ECS, state sync becomes much simpler. In Mud, we have a central contract called the world contract. And every time you create it, that component gets automatically registered on the world contract. And then every time the component value updates, that update also gets registered on the world contract. And then the world contracts emits one single stream of events that the client can listen to, and then use that stream of events to duplicate the state on the client. But the great thing is, MUT handles all of that for you. You don't have to worry about any of that. All you have to do is create a component contract and give it some ID, and then create a component on the client and give it the same ID. And if there's two components with the same ID, then MUT automatically syncs their state. And because this is a very general approach, we can also provide you with generic indexes that just make it faster to load state from the client, or make the RPC load on the RPC node lower. And you don't have to write any custom subgraphs or anything for that. Now to the fun part of adding content. Like I said, in ECS, an entity is just a collection of different components with values. So as an example, our fighter here is in reality just the collection of the health component, the attack component, and the movable component. And now if we want to add more strong units, we can just modify those component values, and suddenly we have a dragon. Or we can recombine existing components in a new way, like removing the movable component, and suddenly we have a defense tower. And for all of that, we didn't have to write any new code. And then if we add a new component, we double the amount of entities that we now can represent with the components we have. As an example, if we add a healing component, suddenly we can represent a healing shrine and a healer and a healing potion with those existing components and that one new component that we added. Now to interoperability. In theory, everything that you build on chain is already kind of interoperable with everything else. You just have to write a custom integration for it. But if you have to write a custom integration for every other game out there, then of course that doesn't scale, and it becomes like tiring quite quickly. So in other words, interoperability needs interfaces to scale. And you can think of MUT as an interface for on-chain games, in the way that when you read from your own world, it's exactly the same as if you would read from another world. And if you think of ERC 721 as an interface for ownership, you can think of MUT basically as an interface for anything, because all the data is stored in a standardized way, and you can access it through standardized queries. Like in this case, has value, or like in this case, this is a query that gives you all the movable attack entities owned by this address. And this is the standardized way how you can get any data out of any other world out there. And the best thing about MUT is that it's completely genre agnostic. In fact, over the last couple of weeks, we've built 2 games that you've already seen if you were here the entire day. One of them is Skystrife, which is an on-chain RTS where the goal is to build your army and then defeat your opponents and steal the loot from the center of the island and escape with it as the first person. And it consists of 39 components, 22 systems, and 0 networking code, because MUT handles all of that for you. And then we built OPCraft, which is an on-chain voxel game that only consists of 8 components, 7 systems, and again, 0 networking code, because MUT handles all of that for you. And those 2 games are completely different games, completely different genres, but they build on the exact same architecture and can share the same tooling. In Skystrife, a golem consists of these 5 components, and in in OPCraft, a grass block consists of just 2 components, position and item, but it's the same basic principles that you build on top of. So as a summary, if you use MUT, you don't have to worry about state sync, because MUT handles all of that for you. You don't have to worry about adding content. Every time you add a new component, you double the amount of entities that you can represent with your components. And you don't have to worry about interoperability, because all the worlds built on top of MUT are by default interoperable with each other. And with that, all the problems of building on-chain games are solved, except from building a game that's actually fun. All right, now to the second part, MUT in practice. Now, let me go over a little case study of a game that we've been working on over the last couple of weeks, OPCraft. You can actually check it out at opcraft.mut.dev if you want to. And like I said, it only consists of 8 components and 7 systems, so I'm actually going to go over every single component right now on every single system and explain you how it works. I'm just going to go very quickly over the components and then explain them further when I explain the systems. So at first we have the item component, which is attached to item entities and basically tells you which type of block that entity is. Then we have the item prototype component, which is a slightly more advanced concept that I will go over in just a second. And we have the recipe component and the occurrence component, which are both attached to the item prototype entity. And then we have the owned by component, which tells you who owns a specific block, and it's attached to the item entity itself. Then we have the position component, which stores the position of a certain block, and it's also attached to the item itself. And then we have two more components, the stake component and the claim component, which are used for our chunk protection system. I'm also going to go over that in just a second. So now to the systems. We have the mine system. It's obviously very, very central in this game. It acts on a couple of components, and basically what it does is it checks whether there actually is, so you send a coordinate to the contract and a type of entity, and then what the system does is it checks whether there actually is a block of that type at that position, and if so, it removes the position component and instead adds the owned by component to that entity. Then we have the build system, which is basically the inverse of the mine system, and it checks whether you own the block that you're currently trying to place, and then removes the owned by component and instead puts the position component on it. Then we have the craft system, which acts again on a couple of components. It checks whether the entities that you send to it are all owned by you, and then if the hash of those entities corresponds to the hash of a known recipe. And if so, it creates a new block and gives it to you. And finally, oh, not finally, but then we have the stake and claim system. Those are two systems, but they work very closely together. With a stake system, you can stake diamonds in a chunk, and then with a claim system, you can claim that chunk for you if you have the highest stake in that chunk. And then somebody else can come and stake more and claim the chunk from you. Then we have the transfer system, which is very trivial. It just transfers, it changes the owned by component, transfers the block from your inventory to somebody else's inventory. And now finally we have the occurrence system, which is not really a system because it doesn't act on any components. It just basically is a pure function, but we still use the system pattern in order to take advantage of the entire MUD infrastructure. And with that, you basically have an overview over the entire architecture of OPCraft. You could have totally done that yourself, it was not hard. And now with now I want to talk about two little things that I found interesting when building OPCraft. The first one is data versus code, and the second one is on-chain terrain generation. For the first part, data versus code, I just mentioned when you want to add new content, you can modify component values or you can add new components. But every time you add a new component, you basically also have to add a new system because otherwise there's no logic that handles this component, right? Adding a new system is basically adding new physics to this world. And whereas adding, like recombining components that you already have is just adding new content to the world. And you kind of want to optimize for only adding content to the, or not only, but you want to optimize for adding content to the world because it's easier to do than deploying a new system that then could have bugs and so on. So one example in OPCraft is the item component. We could have gone the easy way and just stored, like create a block type enum and then store that value inside of the item component in order to represent what type of item or what type of block this item is. And then in our mine system and build system, etc., we would have had to hard code this block enum and then check the occurrence of that block enum and check the recipe, etc. What we did instead is create an item prototype component and then create item prototype entities. And then in the item component, we can just point to those item prototype entities instead of a hard-coded value. And to this item prototype entity now, we can add components that are basically shared by all the grass entities as an example. And there are two components that we add to those item prototype entities that are one, the occurrence component, which includes a function selector to a function that then tells you whether this block actually occurs at this position. And this is used in the mine system. And then we have the recipe component, which is also attached to certain item prototype components, item prototype entities. And it stores the hash of the entity types that you need to burn in, essentially in order to create one of these components. And now what that allows us to do is after the main systems have been deployed, we can just add new component values by creating a new block, like item prototype entity, and attach a new recipe or occurrence component to it, and suddenly we have a new type of block that is still handled by all the existing systems. And the second part that I found really interesting when working on OPCraft is the on-chain terrain generation. Here are a couple of images of the beautiful on-chain terrain that we're generating, in case you haven't seen it in the real game yet. And basically, I just told you that all the blocks in OPCraft are represented as entities with components attached to them. That is not completely true, because if you want to have an infinite procedurally generated world, then obviously you can't represent every single block as an entity in your ECS system or on-chain. What we do instead is we have a function, a closed form function of the entire world, essentially, that gives you, as an input, it takes as an input the coordinate of a block, and then as an output, it gives you the block at that position. And then what we do is just store the difference to this world in ECS. So every time you mine a block, we basically place an air entity at that position, and every time you build a block, we just place the block at that position. So how do you get this closed form function that represents the entire terrain? Step one is you need Perlin noise. Perlin noise is a noise function that was invented by Ken Perlin, and it's very useful to generate these kinds of infinite terrains. And so the first thing you need is basically a Perlin noise implementation in Solidity and a matching Perlin noise implementation on the client, ideally in WebAssembly, such that it is fast enough. And conveniently, Mud already gives that to us, so we don't have to do anything further. And then you could theoretically just use the Perlin output as the height of your world, and now you already would have an infinitely procedurally generated world, but it's not very interesting. So let's add some more interesting stuff to it. Step one, or like step three, I guess, is adding oceans. For that, we scale up the Perlin, and now we have huge valleys and huge like oceans, basically. And we say every time, in our function, we say if the height of the current block is less than 0, but it's above the height of the Perlin, then we put water there. And now we have oceans. But the terrain still looks pretty boring. So next thing is adding something called octaves, which is basically the same thing as when you add different sine curves with different frequencies and amplitudes. Like if you add them up, then you get like more interesting patterns, basically. You can do the same with Perlin noise. And if we do that twice with 2 different octaves, then we get something like this, which is already much more interesting. But it still all kind of looks the same, so we can do better. Next step, let's add some biomes. For biomes, we need basically two more Perlin functions that we, just for our own understanding, call humidity and heat. And then for every point in the world, we can compute the Perlin value for this heat and humidity, and then plot it into this graph. And then in this graph, we like divide the graph into 4 quarters and say, if the heat is high and the humidity is low, then we're in a desert. If the heat is high and the humidity is high, then we're in a savanna, etc. And now, as I said, for every point, we get like a point in this graph, essentially, and then we can compute the distance from these edges of the biome to get a biome vector. And then we can use this biome to say, like, in this case, just represent the block types in a different way, such that you can see where the biomes are. But we can do more interesting stuff, like scaling the terrain depending on the biome, such that in a mountain biome, you get like much higher terrain and like mountains, and in the savanna biome, you get much more flat land kind of things. Next step is adding valleys and rivers to make it, again, a little bit more interesting. And this is where something called a spline function comes into play, spline interpolation. We create the spline function, and then we create a new Perlin function, and don't use the Perlin value directly, but rather map it through this function into a new value. And in the case of rivers and valleys, we basically want not to use the like peaks and the hills and the valleys of the Perlin function directly, but rather the areas of the Perlin function where it's like at the around 0.5, such that the output of that like mapped function is basically the thing you see here on the right. And then we just subtract that from the terrain we have so far, and we get valleys and rivers. And now this looks already much more interesting, but it's still kind of naked. So let's add some plants. For plants, we can just hash the coordinate, the 2D coordinate basically, and then say if the coordinate, or if the hash modulo some value is below a certain threshold, then we put a plant there, otherwise not. And we can do the same for ores if we use the 3D hash of the coordinate. And then we get something like this, where you have at random positions plants growing. And now the final the final touch that's still missing here is something that's bigger than just in like a small flower, a small plant, something like a tree. But for trees, it's slightly more tricky because a tree is not only at one specific coordinate, but rather it spans across like multiple coordinates. So the trick that we use here is basically use a structure, a structure grid, and align our structures on that grid, and then we can map each position, like each individual tile coordinate, to one of these grid coordinates. And then we can use the same trick as before and use the hash of that structure grid coordinate, and then if it's below a certain threshold, we say, okay, there's a structure at this position. And if we know there's a structure at this position, then within the structure grid, we can say, we can figure out if there's a block of this type at this position within this struct, if that makes sense. And that's it, basically. Now we have a beautiful, infinitely generated terrain with flowers and plants and ores and valleys and rivers. And this is basically all you need to know about OPCraft. Now you know where all the diamonds in OPCraft are, so you can mine all of them and build something cool. Thank you.
All right, we have 10 minutes left before being kicked out. I want to first say thank you to all the speakers, so please clap again. They spent a lot of time on their presentations. Thanks for joining us today. Next year, we're going to have the whole conference. This is the genesis of something super cool. I think there's a lot of cool technology, ideas, and like little groups of people that have been emerging there. So if any of you is interested in kind of like collaborating with the people here, learning more about their projects, feel free to reach out right now, otherwise you'll never see them again. Follow ZeroXPark on Twitter. We'll soon tweet something for the people who are interested in learning more and kind of like staying in touch. But yeah, thanks for coming, everybody.